guys, in this video you're going to write your first C++ program, so sit back, relax, and well, enjoy the show. Hey, if you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. I'm going to tell you why you need to learn C++. C++ is a fast language, like really fast. It's commonly used in advanced graphics applications. A few examples would include Adobe applications, video editing software, anything that's graphics intensive. C++ is considered a middle-level language, therefore it's commonly used with embedded systems. And most importantly, it's commonly used with creating video games. I like video games, like a lot. Compared to other programming languages, you could say that C++ is a middle-level language. Programming languages tend to be on a spectrum. The higher level of programming languages, the more it resembles human language. Languages that are closer to being lower level resemble hardware instructions. Higher level languages such as Python, Java, and C# are very easy to write with and to understand, but they tend to be slower. C++ and C, they take a little more effort to write, but they are very fast. They have the benefit of working closely with machine hardware while still somewhat resembling human language. Just a fair warning, there is a learning curve with C++, but if you can learn it, it's worth it. There's two things you'll need to get started. One is a text editor. A few options include, but are not limited to, would be VS Code, Code Blocks, or even Notepad. VS Code and Code Blocks are also considered IDEs, Integrated Development Environments. They are a text editor as well as a workshop that contain a lot of useful developer tools. In this video, I'm going to show you how to download VS Code, but feel free to use any text editor that you're comfortable with. Secondly, we'll need a compiler. A compiler is a piece of software that will parse source code to machine instructions. And that's really it. If you're using Windows or Linux, you'll probably want to go with GCC. If you're running Mac, you'll probably go with Clang. Okay, Clang has a really cool logo. It's Blue Eyes White Dragon. So let's get started. Well, alright then everybody, now we are going to download VS Code, that text editor I was talking about. Head to this URL, code.visualstudio.com. Then select the correct download for your operating system. I'm running Windows, I'll select Windows. Then I will open this. Read the agreement. Yes, I actually did read it that fast. I accept the agreement. Next. 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 I'll create a desktop icon, why not? Next. And install. We might as well launch it. Finish. In VS Code, there's two extensions I would recommend. Go to the left toolbar underneath extensions. We will look up C/C++, and we would like to download this extension. Let's pretend that this wasn't already installed, so I'm going to install it. Then the next extension I recommend is Code Runner. Here it is, and then just click this blue button to install it. Okay, let's close out of this. We're going to create a new folder to hold our C++ projects. Go to the left toolbar, Explore, Open Folder. I'll create a new folder on my desktop. New folder. I'll name this C++ Projects. That sounds good to me. And select folder. Within this folder, we'll create a new file. I'll name this hello world.cpp. Make sure to get that CPP extension at the end. That means it's a C++ file. Okay, we now have a C++ file to work with. Now we just need to download that compiler that parses source code to machine instructions. There's a great set of instructions at this URL, code.visualstudio.com/docs. Let's head to C++. There's different installation instructions depending on your operating system. You'll be downloading GCC on Linux if you're running Linux, GCC on Windows for Windows, and Clang for Mac OS. Downloading a compiler for Linux and Mac is actually really easy. I can cover that in like 30 seconds. Windows is a little more complicated, but let's begin with Linux. So all you're going to do is open up Terminal and enter the following command, gcc/v. That will check to see if it's currently installed. If it's not, you enter this command in. Then you install the GNU compiler tools by typing in this command right here. And that's all you need to do with Linux. If you're on Mac, you'll download Clang, open Terminal, type in this command. If Clang isn't installed, all you type is this command, and that's it. So pretty easy, right? If you're using the Windows operating system, there's way more steps. So let's head to step 3. We'll need to install MinGW W64. You can click this link to the installer. This is an executable. I'll open this when it's done. Click Next, Next, Next. Wait for it. We might as well run this. Then finish. Now we will follow the installation instructions on this website. Under step 5, we will type pacman-SYU, enter. Type Y, then enter to proceed with the installation. Type Y, then enter again to confirm to proceed. Now we'll need to find this program from the Start menu. MSys2, then type this command, pacman-SU, enter. Type Y, then enter to proceed with the installation. Now we'll need to enter this command in. There's a lot to type here. pacman-s needed base dash dev l min gw dash w64 dash x 86 underscore 64 dash tool chain, then enter. Then just hit enter. Proceed with the installation. Type yes. Type Y. Enter again. Then give it a moment. Then we can close out of this window. We'll have to find the bin folder of MinGW. It's likely going to be within your C drive. Go to MSys64, MinGW64, bin, then copy this address. We'll need to add that path to the Windows Path Environment variable. To do so, search Settings, Settings. We'll search Edit Environment Variables. Go to Path, Edit. Let's pretend that this wasn't here. I'm going to go to New, paste that address. OK. OK. Close out of this window. Just to be sure that our compiler is working and available, let's open up Command Prompt. Command Prompt. Then type in this command, G++ -- version. Enter. Yeah, it looks like it's good to go. We have now successfully installed our compiler. Alright everybody, let's write our first C++ program. At the top of our C++ file, we are going to type include, within angle brackets, IOStream. IOStream is a header file that contains functions for basic input and output operations. By writing include IOStream, we're including the header file. Then we have access to a whole bunch of useful input and output operations. Now we'll need a main function. The main function is where the program begins. We'll type int main, parentheses, curly braces. We begin the program by invoking the main function and read any code within the main function, starting at the top and working our way down. At the end of our main function, we'll want return 0, then add a semicolon. If we reach return 0, that means there were no problems in this program. However, if 1 is returned, that means there was a problem, there was an issue. So place return 0 at the end of your main function. What we'll do in this lesson is write some basic output. To write some output, you'll type STD. Contrary to what you might believe, in this case it doesn't mean sexually transmitted diseases. It means standard. Follow STD with 2 colons, then type C out. C means character, out means output. Altogether, this means standard character output. We're going to display some characters as output, then follow C out with 2 left angle brackets. These characters mean output. It's also known as the left shift operator when used with numbers. What characters would we like to display as output? Within quotation marks, let's write something. What's the food you like? I like pizza. I'll type that. Then follow this statement with a semicolon. At the end of statements, we add a semicolon. That lets the compiler know that the statement is done. It's sort of like the period at the end of a sentence. That's when you know the sentence is complete. So I'm going to save this. I'll hold Control S, or you can go to File, Save, then click this button to run it. And there's my output. I like pizza. On the next line, I'll type STD, 2 colons, C out, 2 left angle brackets for output. I'll write a second line. It's really good. Now I'll run this again. You can press this icon to clear your output. Uh-oh, we have a problem. I like pizza. It's really good. All of this text is on one line. What if you need the next line of text to be on, well, the next line? When you need to move your cursor down to the next line, you can follow some string of text with double left angle brackets for output, STD, colon, ENDL. That means end line. And I'll do the same for my second line. I'm going to save, clear my output, run this again. Yeah, there we go. I like pizza. It's really good. Each line of text is on a different line. Another option for a new line that's better performance-wise is to add a new line character. Within single quotes, type \n. And let's replace that here as well. So I'm going to save, clear my output, run this again. I like pizza. It's really good. Adding a new line character does the same thing, and it's better performance-wise. However, the benefit of using endline is that endline will flush the output buffer. Really, you can use either one, but I thought that might be a nice trick to show you. Now, you can write a comment. A comment is ignored by the compiler. To write a comment, you use 2 forward slashes. This is a comment. Comments are used for yourself for notes, or for notes for another developer. So if I were to run this again, this comment is ignored. It's not used as output or anything like that. If you need a multi-line comment, you type /**. Wherever you need your comment to end, you'll place */ again. This is a multi-line comment. And you can see that all of this is ignored as well. So comments are used as notes for yourself or for other developers. Yeah, that's a quick introduction to getting started with C++. I'll post this code in the comment section down below if you would like a copy. If you enjoyed this video, please be sure to smash that like button, leave a rated comment down below, and subscribe if you'd like to become a fellow bro. Hey guys, I'm going to explain what variables are. A variable you probably remember from middle school math class. A variable is a representation of some number or value. There are 2 steps to creating and using a variable: declaration and assignment. We'll begin with declaration. To declare a variable, we need to list the data type of what we're storing exactly. In programming, you can store more than just numbers. You can store characters, even whole sentences, etc. Let's work with whole numbers. To store a whole number, we will type int for integer. Then we need a unique identifier for this variable. For now, let's just say x. We're used to working with like x and y in math class, right? We will end the statement with a semicolon. This step is declaration. Now to assign a variable, you take the variable's name, that unique identifier, then we will set this equal to some number. Since we declare this variable as an int, it will store an integer, maybe like 5. Now this variable behaves as if it was the value that it contains. It will behave as if it was the number 5. Then to display a variable, we can use standard output. std cout. We will display x. And let's see what we have. There's our value, 5. This first step is declaration. The second step is assignment. The nice thing about doing this in 2 steps is that you can later assign your variable a value. If you know what value you would like to give your variable right away, you can do that at the beginning of your program. You could combine both of those steps. Int x equals 5. And that would do the same thing. In cases where you don't know what value you would like to give a variable, you could assign it later, such as when you accept user input. You don't know what the user is going to type. So let's create another. Int y equals 6. And let's display whatever y is. I'll add a new line. Let's copy this, paste it. Okay. X is 5, y is 6. We could even do something like this. Let's say int sum equals x plus y. Then we'll display whatever our sum variable is. Cout sum. The sum of x plus y is 11. Now there's different data types depending on what you need to store within a variable exactly. The int data type stores a whole integer. Let's think of a few examples of whole integers. What about an age? That's typically a whole number. Int age equals 21. Let's think of 2 more examples. What about a year? Int year equals 2023. How about days? Int days equals 7. The int data type can only store a whole number. With days, what if we assign this a value of 7.5? Let me show you what happens. Alright, I will display days. Alright, that decimal portion is truncated. When I display days and we attempt to assign 7.5, well, this variable can't store that decimal, so it's truncated. If you need a number that includes the decimal portion, there's a different data type for that, and that is a double. This is a number including decimal. A few examples of a double would be maybe a price. There's dollars and cents. Double price equals $10.99. What about a GPA, a grade point average? That includes a decimal. Double GPA equals 2.5. Then maybe a temperature. Double temperature equals 25.1. I guess this could be in either Celsius or Fahrenheit. Then let's display maybe price. Price. Yeah, and that decimal portion is not truncated, much like what you see with whole integers. If you need a number that includes the decimal portion, use the double. Now we have the char data type. That stores a single character. Type char. Maybe we're working with student grades. I'll name this variable grade. Equals. Then to store a single character, you use single quotes. This student has an A. 2 more examples. What about an initial? Singular, not initials. Char, initial. What about B? So I'm going to display initial. Initial. Okay. We have our single character of B. Now check this out. What if I attempt to store more than one character? I'll add C. We have a warning. We have an overflow in conversion from int to char. So what's displayed is the last character, just C. So chars can only store a single character. Here's one more example of a char data type. What if we're working with currency? What type of currency will we work with? Char currency equals maybe a $sign. If we're working with a different type of currency, we can change this to a different symbol. Yeah, that's the char data type. It stores a single character. Next on our list is booleans. Boolean. A variable that's boolean has only 2 states, true or false. To create a boolean variable, you type bool, then a variable name. So these are applicable to anything that has 2 states. What if somebody is a student? They're either a student or not a student. Bool student equals true. If they're not enrolled in classes or they graduated, you can set this to be false. Think of a light switch. The light switch can either be on or off. You can say a light switch is Boolean. There's only two states, true or false. How about bool power? Is something powered on or not? Power equals true. If it's turned off, that could be false. Maybe we have a store and we need to mark if something is for sale or not, like is it available? Bool for sale equals true. If an item in our store isn't for sale, like it's not available, we can set this to be false. So that's the idea behind Boolean values. It has two states, true or false. The last data type I'll cover is strings. A string is technically an object that represents a sequence of text. Think of it as the char data type, but we can store more than one character, even whole sentences, like a name or an address. Strings are provided from the standard namespace. To declare a string, we would type standard string, then a variable name. What about just name, like we're storing a user's name? Place your text within a set of double quotes. Then why don't you type your first name? Then we will store that within this variable name. Then to test it, let's display it. Standard output, we will display name. And there is your first name. Let's create a couple more examples. What about a day of the week? Standard string day. Then pick a day. I like Friday. What about food? Standard string food. I like pizza. I'll store this series of text as a string. Then maybe an address. Standard string address equals, make up some address, 123 Bank Street. Basically speaking, a string is a type of object that represents a sequence of text, such as a name, a day, an address, etc. Now I'm going to show you how we can display a variable along with some text. I would like to display hello, then whatever your name is. I will type what is known as a string literal. We're literally printing a string. Hello. Follow this string of text with a variable. My variable name is good. Then let's display it. Hello, then whatever your first name is. But you do have to pay attention to spacing. After the word hello, I'm going to add a space. There. Hello, bro. Then let's display our age. So I'm going to add a new line character. Standard output, we will display you are age, years old. There. Hello, bro. You are 21 years old. Make sure to pay attention to the spacing as well. It's easy to mess that up. Alright, so those are variables. We covered a few of the basic data types, but there's more advanced data types once we gain a little bit more experience with this that I'll cover. We have integers, which store a whole number. Doubles, which are numbers that include a decimal portion. Chars are single characters. Booleans are either true or false. And strings represent a sequence of text. An important note with strings is that you can include numbers, but they're treated differently. So yeah, those are variables in C++. Your assignment is to, in the comment section, post a integer variable, a double, a character, boolean, and a string. Think of some examples, preferably some examples that I may have not covered already. That would be good practice. Well, yeah, and that's an introduction to variables in C++. Alright, welcome back everybody. In this video we're going to discuss the const keyword. The const keyword specifies that a variable's value is constant. It tells the compiler to prevent anything from modifying it so that it's effectively read-only. Here's an example. Let's create a program to calculate the circumference of a circle. We'll first define the variables that we'll need. We have double pi. Pi equals 3.14159. Then we have double radius. Pick some radius. I'll pick 10. Then double circumference equals, and here's the formula to calculate the circumference of a circle. It's 2 times pi times radius. Then we will display our circumference. Standard output, we will display circumference. Then I'll add maybe centimeters. Our circumference is 62.83 centimeters. Any variable we do not want to be able to be changed at all, we can turn into a constant. Let's say that somebody goes into our program and changes pi to a different number, like 420.69. Well then, this is going to change the result of our program. We may have not realized that somebody changed the value of pi to 420.69. So any variable you do not want changed, you can prefix this keyword const. Const double pi. Now a common name you can mention for constants is to make all of the letters uppercase. So let's change pi from lowercase to all uppercase. And we'll need to make that change here as well. Now let's try and change pi to 420.69 again, and then see what happens. Okay, we have an error. Assignment of read-only variable pi. So by including constants, it has some data security. We can't normally change any value that's a constant. A couple other examples on variables that you could turn into constants could be maybe the speed of light. Maybe you have a physics calculator. So const int light speed. The speed of light in meters per second is 299,792,458. Let's think of one more example. Perhaps you're working with screen resolutions. We have const int width of 1920, then const int height of 1080. These may be a few examples of variables you do not want to be changed or altered at all. You only want them to be read-only. Yeah, that's a const, everybody. It's a keyword that will modify a variable or some value so that it's read-only and can't be changed. You should use constants as often as possible, only if you know that a variable is not going to be changed at all. Your assignment is to think of a constant and post it in the comment section. If you're enjoying the series, please be sure to smash that like button, leave a random comment down below, and subscribe if you'd like to become a fellow pro. Hey everyone, I have a quick video on namespaces. A namespace provides a solution for preventing name conflicts, especially in larger projects. Each entity needs a unique name. A namespace allows for identically named entities as long as the namespaces are different. Now, what the heck does that mean? Suppose we have the variable x equals 0. Each variable needs a unique name. I couldn't create a second variable named x and give this a different value. If I were to compile and run this program, we would run into an error. Redeclaration of int x. So each entity needs a unique name. But if we use namespaces, then two or more entities can share the same name. To create a namespace, let's do so outside of the main function. I will type namespace, then some name for the namespace. Let's say first. Then instead of parentheses, I could create a different version of x. I'll give this a different value, like 1. Well, this would run and compile just fine. You can have different versions of the same variable as long as they're within a different namespace. Just for fun, let's create a second namespace. Namespace second x equals 2. This is also valid. So just to demonstrate a few things, I'm going to display what x is. If I don't explicitly state what namespace we're using, we will use the local version of an entity. If I display x, x would be 0. If I would like the version of x that is found within the first namespace, I would take that entity, in this case x, prefix the namespace. Let's say first, then 2 colons. The 2 colons is known as the scope resolution operator. I'm referring to the version of x that is found within the first namespace, and that version of x has a value of 1. If I need the value of x found within the second namespace, I would precede that entity with the second namespace, followed by the scope resolution operator. So that version of x is 2. So entities can have the same name as long as they're within a different namespace. Now, one then the name of a namespace. Let's say first. If we have some entity without a prefix of the namespace, it's assumed that we're using the entity found within that particular namespace. So if I was to display X while we're using a namespace first, X would be 1, and I don't need to add that prefix. But if I need X found within the second namespace, I would still need to prefix it with second. X is 2. If I changed using namespace to second, it's implied we're using the second namespace, and I don't need that prefix. 2. But I still would if I need X from the first namespace. 1. Now there's this evil line called using a namespace STD per standard. Now the reason that people include this line is to save a little bit of typing. If we're using a namespace STD, we don't need to include that prefix when we declare strings, or we display out float Cout, just for example. Like this would still compile and run. However, the standard namespace has hundreds of different entities. Let me show you. Standard. There's a high likelihood of a naming conflict. For example, we have an entity named data. One alternative is that we could say using standard output. That will cut down on some of the repetitions. Or using standard string. It's a safer alternative to using namespace standard. In the future, I'm not going to be using namespace standard because I would like to steer people away from that. But just in case you see that line, you know what it's there for. So in conclusion, a namespace provides a solution for preventing name conflicts. Each entity needs a unique name, and a namespace allows for identically named entities as long as the namespaces are different. So those are namespaces. Hey, if you're enjoying this series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow pro. Hey everyone, this topic I'm going to explain type defs and type aliases. Now, type def is a reserved keyword used to create an additional name for another data type. Kind of like a nickname. It's a new identifier for an existing type. One of the reasons that people use type def is that it helps with readability and reduces typos. Here's an example. In this example, I'll need to include this header file. Include vector. Suppose we have this very long data type, and I would like to give it a nickname, an alias. I would type the keyword in type def, and list the original data type. So we're used to strings, ints, doubles. Well, here's a really complicated one, and of course I don't expect anybody to know this at this level yet. Standard, vector, standard, pair, standard, string, int. So this is one really long data type. This could be a data type for a pair list, but I don't want to have to type all of this. So what I could do is give this data type an alias using this type def keyword. After the original data type, I'll come up with a new name, a new identifier. Let's say pair list. That's a lot easier to write than all of this for the data type. A common convention when using the type def keyword, the new identifier usually ends with _t for type. Now suppose I declare a variable of this data type. Standard vector, standard pair, standard string, int. Let's say the name is pair list. In place of using the original data type, we can use the new identifier. Pair list _t. So that's one of the main benefits of using the type def keyword. We can give a new identifier to an existing data type. It helps with code readability and helps reduce typos. This data type is way beyond our level of understanding right now. Let's try some simple examples. I'll turn this line into a comment. Then get rid of that. Let's create a type def for standard strings. Type def. Then we list the original data type. Standard string. In place of using standard string as the data type, I'll create a new identifier for this data type as maybe just text. Text _t. If I need to create a string, I could use this new identifier. In place of saying standard string, then maybe first name, I can replace the data type with the new identifier if I choose to. Text then I'll set my first name equal to whatever my first name is. Feel free to set it to your own first name, and this variable behaves exactly like a string. So let's display it. Standard output first name, and then we should have our first name. Yeah, there we are. Okay, now let's try this with an integer. Type def, we list the old data type, int. Let's create an identifier for int as number. That's more descriptive. Underscore t. Although it's more to write technically. In place of using the int data type, I could use number t, and this is technically an integer. Let's say age, then make it some age. Standard output, I will display my age, then I will add a new line. Yep, we have our first name and our age. Now, typedef has largely been replaced with the using keyword. That's because the using keyword works better with templates, which is a topic for another video. So in place of using typedef, I recommend using the using keyword. So I'm going to turn these lines into comments. Now, if we were to use the using keyword, we would type using, then the new data type. So let's say text t equals the old data type, standard string. And let's do that with number. Using the new identifier, number t equals int. And that would work the same. We have our first name and our age. The using keyword is more popular than typedef nowadays just because it's more suitable for templates. And like I said, that's a topic for another video. Alright everybody, that is the typedef keyword and type aliases. Typedef, along with the using keyword, they're used to create an additional name, an alias, or nickname for another data type. It's a new identifier for an existing data type. It helps with readability and reduces typos. However, you should really only be using the typedef and using keywords when there's a clear benefit. So yeah, that is typedef and type aliases. Your assignment is to post a typedef in the comment section down below. And well, yeah, those are typedefs and type aliases in C++. Alright everybody, welcome. We are going to discuss arithmetic operators. Arithmetic operators return the result of a specific arithmetic operation such as addition, subtraction, multiplication, and division. Let's say we have 20 students. Int students equals 20. If a new student joins our class, we would like to add one student. Well, if we're working with a variable, we could say students equals whatever students is plus 1. Then we could display this. Standard output, I will display students. The current number of students that we have are 21. There is a shorthand way of writing this too. In place of saying students equals students plus 1, we could shorten this to students plus equals 1. That would be the same thing. 21. If we need to add 2 students, this would be students equals students plus 2, or students plus equals 2. Then we have 22 students. If you need to add 1 to a variable, you could also use the increment operator. This is another option. And the preferred way, if you only need to add 1, you would say students plus plus. We now have 21 students. You tend to see this in a lot of loops, which we'll cover later. Okay, now we have subtraction. Students equals students minus 1. There are now 19 students. We could shorten this to students minus equals 1. There are 19 students. If you need to subtract 2, we could say either students equals students minus 2 or students minus equals 2. That would do the same thing. There are 18 students. Another option is the decrement operator. If you need to decrement a variable by 1, you would say students minus minus. This only subtracts 1 from a variable. There are 19 students. So that's subtraction. To use multiplication, you use an asterisk. I'm going to double the amount of students that we have. Students equals students times 2. There are 40 students. Or we can shorten this to students times equals 2. And again, there are 40 students. For division, you use a forward slash. I'm going to divide our class in half. Students equals students divided by 2. There are 10 students. The shorthand way is students divided by equals 2. There are 10 students. Now check this out. We have 20 students. What if I divide students by 3? We're working with an int variable, so this variable can't hold any decimal portion. 20 divided by 3, that is 6. So any decimal portion is lost, it's truncated. But if we change students to be a double, well then that decimal portion is retained. 6.66 repeating students. If you need the remainder of any division, you can use the modulus operator. Let's create a new variable. Int remainder equals students modulus 2. We'll divide a group of 20 students into groups of 2. Then I'll display the remainder. Okay, 20 divides by 2 evenly, so there's no remainder. But what if we divide students by 3 and get the remainder? Our class of students is being divided into groups of 3 for maybe like a project. But 20 doesn't divide by 3 evenly. Therefore, our remainder is 2. There will be 6 groups of 3 students and 1 group of 2 students. Now, using the modulus operator is a great way to find out if the number is even or odd. Take some value or variable you would like to check, modulus 2. If that number divides by 2 evenly, where the remainder is 0, well, it's even. If the remainder is 1, well then it's an odd number. 21 doesn't divide by 2 evenly. So that is the modulus operator. It gives you the remainder of any division. These arithmetic operators have an order of precedence. We resolve any arithmetic operations that are first within parentheses, then multiplication and division, and lastly addition and subtraction. Perhaps we have this formula. Students equals 6 minus 5 plus 4 times 3 divided by 2. So what do we solve first in this equation? We would check any parentheses first, which there aren't any of. Then we resolve any multiplication and division. So let's go through this. So we have some multiplication here. We would resolve 4 times 3 first. That is 12. Then we have some division. 12 divided by 2 is 6. Then any addition and subtraction. 6 minus 5 is 1. 1 plus 6 is 7. And let's check to see if that's right. So students should be 7. Yep, students is 7. Now you can enforce operator precedence by surrounding some part of your equation with parentheses. I'll surround this part of the equation with a set of parentheses. The new result is negative 7. Well, yeah, everybody, those are some basic arithmetic operators. They return the result of a specific arithmetic operation. Hey, if you'd like a copy of this code, I'll post this in the comment section down below and pin it to the top. And well, yeah, those are some basic arithmetic operators in C++. Hey, what's going on, everybody? In this video, I'm going to explain a very basic type conversion. Type conversion is the conversion of a value of one data type to another. Two ways in which we can do this are implicit and explicit. Implicit is done automatically. If done explicitly, we perceive a value with the new data type. Within a set of parentheses, you list the new data type, put it before a variable or a value. Let's perform an implicit cast. Suppose we have a variable int x. I will assign x the value 3.14. Integers can only hold a whole number. If I were to display x, standard output x, well, the value is 3. We truncated the decimal portion and implicitly converted this number into an integer. What if x was of the double data type? Double x equals 3.14. Well, then we would retain that decimal portion. What would happen if I cast 3.14 as an integer, then assigned it to a double variable? Before the value, add a set of parentheses, then the new data type. I will convert 3.14 to an integer, then store it within this double, x. X now equals 3. It's a whole integer. That is one example of implicit and explicit type conversion. Here's a few other examples. I have character x equals some number, like 100. If I were to display what x was, standard output x, well, we will implicitly explicitly cast this number 100 as a character, we'll convert it using the ASCII table to whatever its equivalent is. The number 100 converted to a character is the letter D. Let's try an explicit cast. I will display the number 100 explicitly cast to a character, and that value is the letter D as output. How is this useful? Suppose we have an online exam. We have to give the user a score. How many questions did they get right, divided by how many questions were total. Let's write something like this. It's correct equals maybe 8. The user has 8 questions that are right. Its questions equals 10. There are 10 total questions. I need to calculate the score as a percentage. We could say double score equals correct divided by questions times 100. Then let's display whatever the result is. Standard output, score, then I'll add a percent sign to the end. 8 divided by 10 is 0.8, right? Times 100, that should give us 80%. We have 0%. Well, that's because we're using integer division. Questions is of the int data type. When we're dividing 8 by 10, we're truncating that decimal portion. We're getting rid of it. Then multiplying whatever remains by 100. I'm going to explicitly cast questions as a double of the double data type. And we should retain that decimal portion. Yeah, there we go, 80%. Where you'll use type conversion, it really varies, but you should be aware that you can do it, such as when using integer division. So yeah, that's type conversion in C++. Hey, if you're enjoying this series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Alright, let's get started everybody. In this video I'm going to show you how we can accept some user input in C++. We're familiar with cout followed by the insertion operator, which is 2 left angle brackets. Well, to accept some input, we would type cin for character input, followed by the extraction operator, which is 2 right angle brackets. Here's a demonstration. Let's ask a user for their name. I'll create a string variable, standard string. The name will be, well, name. Then I'll create a prompt which will ask the user what their name is. Standard output, insertion operator, what's your name? Then to accept some user input, we would type standard cin for character input, extraction operator, then where would we like to store the user input? Let's store it within our variable name. At the end of our program, let's display what the user's name is. Standard output, insertion operator, hello, name. Okay, we're going to have one problem though. If we're using VS Code as our text editor, we need to begin using the terminal tab. Previously, we've been using output, so I can't actually type in anything to this because it's, well, for output. If you're using VS Code, this is what we'll need to do. If you're not, you can skip this step. We're going to go to File, Preferences, Settings, look up Code Runner. Then we are looking for Run in Terminal, which is right about here. Check that. Close this tab. Let's stop this from running, and we'll run it again. Okay, here we go. What's your name? I'll type in my first name, hit enter. Hello, bro, or whatever your first name was. This time, let's ask a user for what their age is. I'll store this within a variable named age. Int age. Standard output. What's your age? Standard input. Extraction operator. Age. Standard output. Insertion operator. You are age years old. And I think we'll need some new line characters right about here, just one. Okay, this should work. Let's try it. What's your name? I'll type in my first name. Hit enter. What's your age? I'll make up an age. I like to think that I'm 21 still. Hit enter. Hello, bro. You are 21 years old. So that's how to accept some user input. You can use cin for character input. But there's just one problem though. If you type in a string that has spaces, well, once we get a space, we stop reading that string. This time, let's ask a user to type in their full name. Okay, type in your first name and your last name. Hit enter. What's your full name? Bro. Code. What's your age? Hello, bro. You are 0 years old. If we need to read a string that could contain spaces, there's a function that we can use to help us with that. That is the getLine function. Standard getLine, add a set of parentheses. Within the parentheses, we will type standard cin, then comma, our variable name. Now we should be able to type in a string, including any spaces. What's your full name? Type in your own first name and last name. Hit enter. What's your age? I'll type in 21. Hello, bro code. You are 21 years old. If you need to accept a string that includes any white spaces, you're better off using the getLine function. And if you forget, I'll post this in the comment section so you can always take a look at it if you don't remember. Okay, there's just one issue with this though. I'm going to move the second question above the first. Let's take a look to see what happens. What's your age? 21. What's your full name? Hello. You are 21 years old. Here's the issue. If we accept some user input with cin followed by getLine, well, in our input buffer, there's a new line character, and we don't pick up that new line character. When we reach the getLine function, it accepts the new line character that's still within the buffer. So to prevent that from happening, there's one change that we can make to the getLine function. After cin, add this extraction operator, standard WS for any white spaces. This portion will eliminate any new line characters or any white spaces before any user input. So let's try this again. What's your age? I'll type in 21. Type in your full name. And there we go. Hello, bro code. You are 21 years old. So yeah, everybody, that's how to accept some user input. Basically, you could just use cin followed by the extraction operator. But if you need a string that could include spaces, I recommend using the getLine function. So yeah, that's how to accept some user input in C++. If you would like a copy of all this code, I'll post this in the comment section down below. And well, yeah, that's how to accept some user input in C++. Hey guys, in this video I'm going to show you 8 useful math-related functions in C++. Let's begin by creating 3 variables. Double x, and I will set this to be 3. Double y, that will be 4. Then double z, we will declare this but not yet assign it. The first useful math-related function is the max function, which will return the greater of 2 values or variables. I'll assign the results within z. Z equals standard max, parentheses. Within the parentheses, add 2 values or variables. I'll compare x and y. Then let's display the results. Standard output, I would like to display whatever z is. The greater number between 3 and 4 is, well, you guessed it, 4. Alternatively, there's the min function. Z equals standard min, let's compare x, then y. So the minimum between these 2 values would be 3. So that's max and min. Now the rest of these functions are found within the CMath header file. At the top of our file, let's include CMath. We have the pow function to raise a base to a given power. Z equals pow. For power, let's raise 2 to the power of 3. Z would be 8. 2 to the power of 4 would be 16. That's the power function. Then we have square root. Z equals sqrt. What's the square root of 9? Well, the square root of 9 is 3. Then we have absolute value. Z equals abs. If you place a negative number within the absolute value function, it will give you the positive version of that number. How far it is away from 0. So negative 3, the absolute value of negative 3 would be 3. That is the absolute value function. Next we have the round function. Let's change x to 3.14. Z equals round. let's round x. 3.14 rounded would be 3. If you need to round up, there's a ceiling function. Z equals ceil. Ceil means ceiling. Let's round x. X rounded up is 4. Alternatively, there's the floor function, which will always round down. Let's change x to 3.99 to test it. Z equals floor x. X rounded down is 3. So yeah, everybody, that is a super quick video on a few useful math-related functions. If you head to this URL, c++.com/reference/cmath, there's a lot more useful math functions that you may be interested in, but we just covered a few of the basics. In the next topic, we're going to create a practice program to find the hypotenuse of a right triangle. So yeah, those are a few useful math-related functions in C++. Okay, everybody, this is going to be a practice project to calculate the hypotenuse of a right triangle, which we can find with this formula. C equals the square root of a squared plus b squared. We'll begin by declaring our variables. Double A, double B, double C. Make sure you include the CMath as well, because we'll be using the power function as well as the square root function. At this point, we'll accept some user input for sides A and B. Standard output, we'll create a prompt. Enter side A. Standard input A. Then we'll be side B. Standard output. Enter side B. Standard input B. We can handle this formula step by step. We could reassign A equal to power function A to the power of 2. B equals power function B to the power of 2. Side C equals the square root of A plus B. At the end, we will display whatever side C is. Standard output side C C. Okay, let's try this. Enter side A. I'll type in 3. Side B will be 4. Side C is 5. We could shorten this code too. We could say the square root of A to the power of 2 plus B to the power of 2. Then we no longer need these two lines. That's another way of writing it in less lines of code. Let's try this again. This time side A will be 4, side B will be 5, side C is 6.4. So yeah, everybody, that's a simple practice project just to get us used to accepting user input, as well as some math-related functions. If you would like a copy of this program, I'll post this in the comment section down below. And well, yeah, that's a simple practice project in C++. Alright guys, we are on if statements. With an if statement, you do something if a condition you set is true. If not, then don't do it. It's as simple as that. We'll ask a user what their age is. If their age is greater than or equal to 18, they'll be allowed into our site. If they're under 18, well, we won't let them in. Let's declare variable age, int age. Then we'll create a prompt. Standard output, enter your age. Standard input age. Okay, this is how to write an if statement. You type if, then a set of parentheses, then a set of curly braces. If some condition within the parentheses is true, you perform some subset of code. We're going to check if age is greater than or equal to 18. Greater than or equal to is a comparison operator. There's other comparison operators such as less than or equals to, less than, greater than. If you need to compare if two values are equal, you use two equal signs. You don't want to say age is greater than or equal to 18. Then we'll print a message. Standard output, welcome to the site. Okay, let's try this. Enter your age. Let's say that I'm 12. Well, it doesn't do anything. Since this condition evaluated to be false, we skim over this body of code. If it were true, then we execute it. This time my age is 21. I hit enter. Welcome to the site. If you would rather do something else if the condition is false, you can use an else statement. An else statement you will place at the end. There is no condition. Else, we will print standard output, you are not old enough to enter. Okay, let's try this again. Enter your age. I'll say that I'm 12. You are not old enough to enter. That's an if statement. If some condition is true, you do something. If not, you can do something else, or nothing at all. There are more conditions you can check by using an else if statement. We can check another condition by adding else if. If this condition is false, check this else if condition. Let's check to see if age is less than 0. That means somebody hasn't been born yet. You haven't been born yet. Okay, now check this out. Let's say that my age is -10. And I hit enter. You haven't been born yet. Since this condition was false, we skip this section of code. Then we check the else if statement. Since this condition is true, we execute this body of code, then skip over the else statement. Let's add one more else if statement. Else if age is greater than or equal to 100. Standard output, you are too old to enter this site. Okay, enter your age. I am 120 years old. I hit enter. Welcome to the site. We check these conditions one by one starting from the top. We stated that our age was 120 years old. Even though we were expecting to execute this body of code, we instead executed this body of code within the if statement. That's because our age was technically still greater than or equal to 18. So the order of your if and else if statements does matter. It makes a difference. If we need to execute this body of code if somebody's age is greater than or equal to 100, well then we should probably move that to the top, then turn it into an if statement. Else, if age is greater than or equal to 18, we will display this message. Let's try this one more time. Enter your age. I am 120 years old. I hit enter. You are too old to enter this site. So yeah, that's an if statement. You do something if a condition is true. If not, then you don't do it. If you would rather do something else, you can use an else statement. If there's other conditions you would like to check before reaching the else statement, you can use an else if statement. And there's really no limit to these. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are if statements in C++. Alright everybody, today we're going to discuss switches. A switch is an alternative to using many else if statements. It compares one value against many matching cases. Here's an example of what you don't want to do. I have this program. We have variable month. Month is of the integer data type. The user will type in a number 1 through 12 to represent the month. If month is equal to 1, it is January. Else if month is equal to 2, it is February. Else if month is 3, 4, 5, so on and so forth. This is what you don't want to do because it's inefficient. It's how the game Yandere Simulator was created, if you know what that is. A better solution would be to use a switch. This is the right one. I'm going to delete all of this. We will type switch, parentheses, curly braces. What value would we like to examine against matching cases? Let's examine our month. To write a case, we would type case, then the value. Let's check to see if month is equal to 1. So case 1, colon. On the next line, what do we want to do if month is equal to 1? Let's display a message. Standard output, it is January. At the end of this case, add break, to break out of the switch. So that is case 1. Let's work on case 2. So case 2, it is February. I think the rest is self-explanatory. I'll speed up the footage. We have our 12 cases, 1 through 12, each case corresponding with a month of the year. Let's run this. Enter the month. Let's say that the month is 4 for April. It is April. One more time. The month is 12. It is December. So switch is an alternative to using many else-if statements. It's more efficient and easier to read. If there are no matching cases, we can execute a default case. Type default. Then what would we like to do? Standard output. Let's say, please enter in only numbers 1 through 12. Enter the month. Let's type -42. Please enter in only numbers 1 through 12. So the default case is kind of like the else statement. If there are no matching cases, we execute whatever's within the default case. Let's try one more example. This time we'll have the user enter in a character, a letter grade. We'll display a custom message depending on what grade they have. Char grade. Standard output. What letter grade? Standard input grade. Then we'll create a switch. Switch, parentheses, curly braces. We're examining our letter grade against matching cases. The first case will be the character A. What will we display if somebody receives an A? Standard output. You did great. Then break. Case B. Standard output. You did good. Then break. Case C. Standard output. You did okay. Break. Case D. Standard output. You did not do good. Break. Case F. Standard output. You failed. Break. Then let's add a default case. Please only enter in a letter grade A through F. Let's try it. What letter grade? I received an A. You did great. What letter grade? F. You failed. Then let's test our default case. What letter grade? Pizza. Please only enter in a letter grade A through F. So yeah, that's a switch, everybody. It's an alternative to using many else-if statements. It's more efficient and easier to read. Your assignment is to create a switch and post it in the comments section. And well, yeah, those are switches in C++. Hey guys, in this video we're going to create a simple calculator program. Now that we know how switches work, this will be a very simple program. Let's begin by declaring our variables at the top. We'll need a character for an operator. We'll name this OP. The operator will be either addition, subtraction, multiplication, or division. Double num1, double num2, double result. This next part isn't necessary, but I'm just going to add one line of text when we begin the program. I'll add a bunch of asterisks. Let's say calculator. Then I'll add a new line to the end. Wherever my program ends, I will create another line of asterisks. And I can get rid of that new line character. Our code for our program will be within these two lines of output. Let's ask the user what operator they would like. Standard output. Enter either addition, subtraction, multiplication, or division. Standard input. We'll store the response within the variable OP. Standard output. Enter number 1. Standard input. Num1. Let's copy these two lines, paste them, change one here and here. Now we need a switch. Switch, parentheses, curly braces. We're examining our operator against matching cases. The first case will be addition. Make sure the operand is within single quotes because it's a character. If the user wants to add two numbers, we'll say result equals num1 plus num2. Display the result. Standard output will display the word result, followed by the variable result. Then I'll add a new line to the end. Then break. Then we need a case for subtraction. Case subtraction, num1 minus num2. Multiplication, case multiplication, num1 times num2. Then division, case division, num1 divided by num2. What if somebody doesn't type in a valid operator? Let's add a default case. Default, standard output, that wasn't a valid response. Then break. I'll add a new line too. Okay, we are good to go. Let's save, run this. Calculator. Let's add two numbers. Enter number 1, 1.23. Enter number 2, 3.14. The result is 4.37. Let's run this again. We will subtract the numbers. 1.23 minus 3.14 is negative 1.91. Let's multiply two numbers. 1.23 times 3.14. That's 3.8622. Now we will divide two numbers. 1.23 divided by 3.14. That is 0.39172. Let's type in an operator that's not valid. How about a W? Enter number 1, 1.23, 3.14. That wasn't a valid response. Actually, I think it would be better if we said that wasn't a valid operator. Alright everybody, that is a simple calculator program in C++ using a switch. If you would like a copy of this code, I'll post this in the comment section down below. If you're enjoying this series, please let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro. Okay guys, we are talking about the ternary operator, which is represented by a question mark followed by a colon. It's a replacement to using an if-else statement. You write a condition, then add a question mark, kind of like you're asking a question. Is something true? If that condition is true, we can do some code. If it's false, we do some other code. Here's an example. We have a grade. My grade is 75. If grade is greater than or equal to 60, I'll output you passed. Else, we'll output you failed. My grade is 75. Therefore, I passed. Another way of writing this is to use the ternary operator. First, we write a condition. So let's get rid of this if statement. After our condition, we'll add a question mark. Now, parentheses are optional. Then we write some expression. Standard output, you pass. We do this if our condition is true, colon, what will we do if that condition is false? Well, let's use whatever's within our else statement. And this would work the same. If my grade is 75, you pass. If it's 50, you fail. Let's come up with a few other examples. Let's check to see if a number is even or odd. Int number equals, what about 9? We write a condition. We'll check if number modulus 2. Remember, modulus gives you the remainder of any division. Does the number divide by 2 evenly? So this returns a 1 or a 0. If number modulus 2 is equal to 1, question mark, then let's display odd. If it's false, we'll display standard output even. Okay, odd. Let's change number to 8. Now it's even. You don't necessarily need equals 1 or equals 0. The number 1 does correspond to true, and 0 corresponds to false. So you could write it like this too. 8 divides by 2 evenly, that's even. If it's 9, that is odd. Okay, last example. Let's examine a Boolean variable. Bool, how about hungry? Is somebody hungry? I'll set this to be true. Let's write our condition. Hungry equals true, question mark. Now, if you're examining to see if a Boolean variable is true, you don't necessarily need equals true. You can just say that Boolean variable. Hungry, question mark, like you're asking a question. So if hungry is true, we will do this. Standard output, you are hungry, colon, what will we do if it's false? Standard output, you are full. Hungry is set to true. You are hungry. If it were false, you are full. If we're displaying output, there's a couple different ways in which we could write this. It's up to you how you want to handle it. So another way of writing the same code would be standard output, then within a set of parentheses, then we could use our ternary operator. Hungry, question mark, you are hungry, else you are full. This would work as well. Let's just check that. Hungry is set to false. You are full. Let's set it to true. You are hungry. So yeah, that's the ternary operator, everybody. It's a question mark followed by a colon. You write a condition as if you're asking a question. If that condition is true, you do some expression. If not, you do some other expression. It's a replacement to an if-else statement. Your assignment is to post a use of the ternary operator in the comment section. And well, yeah, that's the ternary operator in C++. Hey guys, in this video I'm going to discuss the AND, OR, as well as NOT logical operators. We'll begin with AND. The AND logical operator will check to see if two conditions are true. Here's an example. We'll ask a user what the temperature is. Int temp short for temperature. Standard output, this will be a prompt. Enter the temperature. Standard input temp. With the AND logical operator, we check to see if two or more conditions are true. Let's see if our temperature falls within a certain range. If condition, then a set of curly braces, we'll check to see if our temperature is above 0. If temp is above 0 and temp is less than, let's say, 30. In order for us to execute this if statement, both of these conditions must be true. This condition and this condition must be true. If one of those is false, we skip over this if statement. So if our temperature falls within that range, the temperature is good. Else, standard output, the temperature is bad. Okay, let's try it. Enter the temperature. Let's say it's 25 degrees. This will be in Celsius. The temperature is good. Let's try it again. What about negative 100 degrees Celsius? The temperature is bad. Yeah, no kidding. One more time. Positive 100 degrees Celsius. The temperature is bad. So with the AND logical operator, we check to see if two or more conditions are true. There's another way of writing the same program too. We can use the OR logical operator, which is represented by two vertical bars. It checks to see if at least one of two conditions are true. If temp is less than or equal to 0, or temp is greater than or equal to 30, the temperature is bad, else the temperature is good. In order for us to execute this if statement, only one condition has to be true. If both of them are false, we don't do anything. What's the temperature? The temperature is 25. That's within that range. The temperature is good. One more time. Enter the temperature. It is negative 100 degrees Celsius. The temperature is bad. Alright, so that's the AND as well as the OR logical operator. There's one more, the NOT logical operator, which is an exclamation point. It reverses the logical state of its operand, meaning if the condition is true, it becomes false. If it's originally false, it becomes true. Let's create another variable. This will be a Boolean sunny. Sunny can be true or false. I'll write another if statement. If sunny is equal to true. Now, if you're examining to see if a Boolean variable is true, you don't necessarily need to say equals true. You can just type the name of the Boolean variable. If sunny. If sunny is true, we'll display a message. Standard output. It is sunny outside. Else, standard output. It is cloudy outside. Okay, one more time. So the temperature is 20 degrees Celsius. I should probably add some new line characters. There. So the temperature is 25 degrees Celsius. The temperature is good. It is sunny outside. If we use the NOT logical operator, we can precede a condition with an exclamation point. We're checking to see if it's not sunny. That means we would want to change our output. It is cloudy outside, else it is sunny outside. Let's change sunny to be false. And so the temperature is 50 degrees Celsius. The temperature is bad, it is cloudy outside. So yeah, everybody, those are logical operators, and or not. Your assignment is to use either the and or otherwise not logical operator. Then post it in the comment section down below, whatever you wrote. So yeah, those are logical operators in C++. Okay guys, in this video we're going to create a temperature conversion program to convert from Fahrenheit to Celsius or Celsius to Fahrenheit. At the top of our program, let's declare our variables. Double temp. Temp is short for temperature, then char unit. Will the user select Celsius or Fahrenheit? Now with my programs, I like to add a title at the beginning. Standard output. Temperature conversion. It's totally not necessary, but it's something that I like to do. Then I'll add another line of output at the end of my program to show the user that the program is over. I'll just add a bunch of asterisks. Like I said, totally not necessary, but it's something I just like to do. I will display a couple lines of output. F equals Fahrenheit. I can never spell Fahrenheit right. I think that's okay. I'll add a new line. Standard output C equals Celsius. Add a new line. Standard output. What unit would you like to convert to? Standard input unit. The user will hopefully type in F or C, depending on what they want to convert to. Let's check to see if the user types in F first. If unit is equal to the character F, that's a capital F. Well, maybe the user types in lowercase f. I'll add an OR conditional operator. Or unit is equal to a lowercase f. That's also a valid response. If the user would like to convert a temperature to Fahrenheit, these are the steps we can do. Standard output. Enter the temperature in Celsius. Standard input temp to store the temperature. To convert our temperature from Celsius to Fahrenheit, we can assign temp equal to, now here's the formula, 1.8 times our temp plus 32. Then we will display the temperature. Standard output temperature is temp degrees Fahrenheit. Then I'll add a new line. If the user would like to convert to Celsius, I'll add an else if statement. Else if unit is equal to the character capital C, or unit is equal to the character lowercase c. We can copy these two lines of code and reuse them. We'll just repurpose them. Enter the temperature in Fahrenheit. Here's the formula to convert from Fahrenheit to Celsius. Temp equals our current temperature minus 32 divided by 1.8. Then let's display our temperature. I'll copy this line of code, paste it, change Fahrenheit to Celsius. Now what if the user doesn't type in a valid response? Else, standard output, please enter in only C or F. Add a new line. And that should be everything. Let's try this. Temperature conversion program. What unit would you like to convert to? I would like to convert to Fahrenheit. Enter the temperature in Celsius. So what's 0 degrees Celsius converted to Fahrenheit? That is 32 degrees Fahrenheit. Let's go again. Let's convert to Celsius. Enter the temperature in Fahrenheit. What's 100 degrees in Celsius? 37.7 degrees Celsius. Let's type in a response that's not valid. I would like to convert to pizza. Please enter in only C or F. Alright everybody, that is a program to convert from Fahrenheit to Celsius or vice versa. I thought we could use some practice using conditional operators, as well as if statements. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a temperature conversion program in C++. Hey, what's going on everybody? So in this video, I'm going to explain some useful string methods that you might be interested in. Let's begin by creating a variable named name. Standard string name. We'll accept some user input. We'll need a prompt. Standard output. Enter your name. A user's name may contain spaces. We're better off using the getLine function. Standard getLine. Standard cin name. The first useful method is the length method. length method is greater than 12, we'll print a message such as your name can't be over 12 characters long. Standard output, your name can't be over 12 characters. Else we'll print a different message. Standard output, welcome the user's name. Enter your name, type in your full name. Welcome, whatever your name is. Okay, now what if our name is over 12 characters? Type in your full name, and just add a bunch of characters. Your name can't be over 12 characters. That is the built-in length method of strings. You type a string, follow it with dot, length, parentheses. Wherever you invoke this method, in that spot you will return the length of that string in characters. The empty method will return if a string is empty or not. Type your string, name, dot, empty, parentheses. This returns a Boolean value. If name is empty, we'll display a message. You didn't enter your name. Else, hello, whatever your name is. Okay, I'm just going to hit enter. You didn't enter your name, but if I do enter my name, it works normally. Hello, whatever your name is. That is the empty method of strings. You'll check to see if a string is empty or not. A useful case of this is to check to see if somebody enters in some user input. Another is clear, name.clear. Then let's display our name. Standard output, hello, name. Enter your name, type in your first name and last name. Hello, and we don't have a name anymore because that name has been cleared. So that is the clear method. We can append a string to another string. After my name, I will use append, parentheses. Within the parentheses, we can add a string to the end of another string. I'll add @gmail.com. Standard output. Your username is now name. Enter your name. Your username is your name with @gmail.com appended to it. That is the append method. We can return a character at a given position within a string. Standard output, type your string, name, dot, at, parentheses. So the first character in a string has an index of 0. I'll display whatever that character is. Enter your name. So the first character in my string is a capital B. The character at index 1, well, that would be R. We can insert a character at a given position. Type your string, follow it with insert. There will be 2 arguments we'll list within the parentheses. An index, so the beginning of our string would have an index of 0, comma, then what would we like to insert? I'll insert the @ sign at the beginning of my name. Then let's display our name. Okay, so we now have the @ sign inserted at the beginning of our string. Or you could pick a different position. The index of 1 would be the second character technically. So yeah, pick a position, then you can insert a string. Now we can find a certain character. I would like to find if there's any spaces within my name. Name.find. Then place a character. I'll look for any white spaces. This method will give me the position of the first space. Type in your first name and last name. The index of the first white space within my name has an index of 3. The first character is always 0. 0, 1, 2, 3. Okay, then lastly, erase. Name dot erase. We can erase a portion of a string. We'll need a beginning index and an ending index. I'll eliminate the first three characters. Then we will display our name. Enter your name. Okay, and that's what's left of my name. I deleted the first three characters. The first number is the beginning index. The second is the ending index. It's not inclusive though. So yeah, those are a few helpful string methods. If you would like to know more, head to the string class on the C++.com website. And there's a fairly extensive list. Hey, if you're enjoying the series, let me know by smashing that like button, leave a rating comment down below, and subscribe if you'd like to become a fellow bro. Hey everybody, in this video I'm going to explain while loops. A while loop is much like an if statement, except we can repeat some code potentially an infinite amount of times. Here's an example of where a while loop would be useful. Let's say that we'll have a user enter in their name. Standard string name. At first I'll use an if statement. If name, I'll check to see if the name is empty. Did the user actually type in something? If name is empty, we'll create a prompt. Standard output, enter your name. Standard get line, standard input, name. Once we exit the if statement, we'll display a message involving the user's name. Standard output, hello, name. Enter your name. I'm just going to hit enter and not enter anything. Hello? And I don't have a name. What if we need to force the user to do something in order to continue with the rest of the program? Well, we could change this if statement to a while loop. If this condition remains true, we will execute this code a potentially infinite amount of times. Once we reach the end of this code block, we check the condition again. If it's still true, we repeat the code again. Enter your name. I'm going to hit enter. Enter your name. No. Enter your name. No. Enter your name. No. So I can't actually continue with the rest of my program until I type in something. I'll type in my full name. Hit enter. Hello? Whatever your name is. Basically speaking, a while loop is kind of like an if statement, except it can repeat some code infinitely as long as this condition remains true. We check this condition once when we enter the while loop. Then anytime we finish the while loop, we check the condition again. If the condition is false, we exit, then continue on with the rest of the program. You do want some way to exit the while loop. Let's write a condition that we won't be able to change at all. While 1 is equal to 1. There's no way we can escape this while loop. So this is what's known as an infinite loop. I'll display a message. Help. I'm stuck in an infinite loop. And then when I run this, yeah, we're stuck in an infinite loop and we can't actually move on or do anything. So yeah, that's basically a while loop, everybody. While some condition that you set remains true, you will continue to execute some code. A great use of a while loop is that you can force a user to do something in order to continue with the rest of the code. Your assignment is to use a while loop, then post it in the comment section down below. And well, yeah, those are while loops in C++. Alright everybody, do while loops. A do while loop, it does some block of code first, and then you repeat that block of code if a condition is true. Here's an example. Let's write a program that will ask a user to enter in a positive number. First we'll use a while loop, then I'll demonstrate how a do while loop would actually be better for this situation. We have an integer number, int number. I'll write a while loop. While number is less than 0, we will prompt the user to enter in a positive number. Enter a positive number. Okay, standard input number. Outside of the while loop, at the end of our program, let's display the number. Standard output. The number is number. So this isn't going to work normally. Here's why. Let's run this. The number is 0. So this is what's going on. We've declared our number, but have not assigned a value quite yet. When we reach the while loop, we check the condition. If the condition is true, we execute this block of code. Since we've declared an integer variable but have not assigned it a value, it's defaulting to just 0. 0 is not less than 0, so this condition is false. That means we skip the while loop and continue on. Another way in which we could write this, but it's not the best solution, is that we could copy what's within this block of code, then run it once. If number is still less than 0, we would then execute this block of code repeatedly. Let's try this again. Okay, enter a positive number, 1, 2, 3. The number is 1, 2, 3. Let's type in a negative number, -1. Enter a positive number, -1. Enter a positive number, -1. So I can't actually continue until I enter in a positive number. You know, this does work, but there's a much better way of writing this because, you know, we're repeating at least 2 lines of code when we really don't need to. We need to run this block of code once and then repeat it if this condition is true. Well, you know what would be great for that? A do while loop. Let's eliminate these 2 lines of code. To create a do while loop, we will move this condition to the end. While, then our condition, preceding the left curly brace, right, do. Do this code once, and then check the condition, and make sure you have a semicolon at the end. Let's try it again. Enter a positive number. I'm just going to type in a negative number. -1, nope. -1, nope. I want a positive number, 1, 2, 3. The number is 1, 2, 3. So that's a do while loop. You do some block of code first, then you repeat it again if the condition is true. It's an optional way to repeat some code. One good use of a do while loop that comes to mind, maybe we're playing a game. We would like to run the game once. At the end of the game, a user can choose if they would like to play again. Based on the user's input, if they would like to play again, we can run the game one more time, repeatedly. So that's a do while loop, everybody. I'll post this code in the comment section down below. And well, yeah, that's a do while loop in C++. Alright guys, in this video I'm going to explain for loops. A for loop is a loop that will execute a block of code a specified amount of times. To create a for loop, we type for, parentheses, curly braces. Within the for loop, there are up to 3 statements that we can add. The first is that we can create an index, a sort of counter. Int, index, I'll set this equal to be, we'll start at 1. Then finish the statement with a semicolon. Now what a lot of people do, instead of saying index, they'll just shorten this to I. The second statement is a stopping condition. Let's count up to 3. I'll continue this as long as I is less than or equal to 3. Then semicolon to finish that statement. The third statement is that we can increment or decrement our counter, our index. I'll increment my index by 1 by saying I plus plus. Okay, let's repeat something 3 times. Standard output. How about Happy New Year? Happy New Year. This code should be repeated 3 times. Happy New Year, Happy New Year, Happy New Year. I should probably add a new line. Now let's try this 5 times. We'll begin I at 1. We'll continue this as long as I is less than or equal to 5. Okay. 1, 2, 3, 4, 5. That's it. This time, let's count up to 10. Then display Happy New Year once we exit out of the for loop. I'll move this line to outside the for loop. I'll set I to be 1. We'll continue this as long as I is less than or equal to 10. During each iteration of the for loop, I will display whatever I is. Standard output I. Then I'll add a new line. Okay. Here we go. We're starting at 1, then we're counting up to 10, then we escape the for loop. Once we escape the for loop, then we print Happy New Year. When you increment or decrement your counter, you can skip iterations. Let's increase I by 2 after each iteration. I plus equals 2. Now we're counting up by 2s. 1, 3, 5, 7, 9, Happy New Year. We can even set our index to be a different number. Let's begin at 0. We're still counting up by 2s. 0, 2, 4, 6, 8. Happy New Year. We could even increment I by 3. 0, 3, 6, 9, Happy New Year. Or we could decrement and go backwards. I minus minus. This time we will begin at 10 and continue as long as I is less than or equal to 0. So this would be a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Happy New Year. Okay, let's decrement I by 2 after each iteration. I minus equals 2. 10, 8, 6, 4, 2, 0. Happy New Year. So yeah, everybody, that's a for loop. There's a lot of overlap where you could use either a while loop or a for loop. For loops tend to be better in situations where you only need to repeat code a certain amount of times. Your assignment is to post a use of the for loop in the comment section down below. And well, yeah, those are for loops in C++. Hey everybody, so in this video I'm going to explain the break and the continue keywords. The break keyword will break out of the loop. Another place where you see this is a switch. Within a switch statement, continue will skip the current iteration. Here's an example. Let's create a for loop that will count up to the number 20. I'll set I equal to be 1. I will continue this as long as I is less than or equal to 20. Then increment I by 1. Standard output, I'll display whatever I is. Then I'll add a new line. New line. Then let's take a look. So we have the numbers 1 through 20. I would like to skip the number 13 because 13 is considered an unlucky number. I know it's a weird example. What I'll do is use this statement within my for loop. If I is equal to 13, first we'll break, then see what happens. If we break where I equals 13, then we have the numbers 1 through 12. Once we hit 13, we break out of the loop. We do not finish the rest of the iterations. If we replace break with continue, this is instead what happens. We have the numbers 1 through 20, but the number 13 isn't there. So using the continue keyword, we skipped the current iteration. So yeah, that's the break and the continue keywords. These keywords are available if you need them, but where you'll use them, it really depends. But just so you know, they exist. And that is the break and the continue keywords in C++. Alright guys, we are on nested loops. A nested loop is just a loop that's inside of another loop. It doesn't matter what kind of loop you're working with. It can be a while loop or a for loop or whatever. Here's an example. We'll create a loop to count the numbers 1 through 10. We'll count to 10 3 times. So let's create a basic loop for now. Int I, I'll set this equal to be 1. The condition will be I is less than or equal to 10. Then I will increment I by 1. During each iteration, I will display whatever I is. Then I'll add a space. There. This loop will count up to 10. Just like that. So now I would like to count up to 10 3 times. Well, I can stick this loop in another loop. So let's create the outer loop. For int I, I'll set this equal to be 1. I'll continue this as long as I is less than or equal to 3. Then increment I by 1. So I'm going to take this loop and stick it within the curly braces of the outer for loop. However, you don't want these loops to have the same index. A common naming convention for the inner loop is to use J as the counting index. J, 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 J. Okay, let's take a look. Okay, now we count up to 10 3 times. Well, what I think I'm going to do is that every time we exit the for loop, the inner for loop, I'll just print a new line character. Standard output, new line. Yeah, that's much better. So yeah, nested loop is just a loop inside of another loop. Just as a practice project, let's create a program that will print a rectangle made out of symbols. We'll let a user specify how many rows and columns. We'll use our nested loop that we created previously. So we have int rows, int columns, then char symbol. We're going to ask for some user input. We'll need some prompts. Standard output, how many rows, standard input, rows. Let's copy this, paste it, change rows to columns. Then enter a symbol to use. Standard input symbol. We'll continue printing rows as long as I is less than or equal to rows. Whatever we type in, we don't want any more rows than what the user wants. The inner loop is going to be in charge of the columns. J is less than or equal to columns. In place of printing J, let's print our symbol, whatever the user picked. And we do not need to separate these with any spaces. Alright, let's try this. How many rows? What about 3 rows? Then 6 columns. Enter a symbol to use. What about the @ sign? And there's our rectangle. There's 3 rows and 6 columns. Let's try it one last time. How about 4 rows and 5 columns? I'll use a $sign. Okay, we have 4 rows. 1, 2, 3, 4. 5 columns. 1, 2, 3, 4, 5. So yeah, everybody, that's a nested loop. It's a loop that's inside of another loop. When you'll use these, it really depends on the situation. I thought this would be a fun practice project. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are nested loops in C++. Hey, this is Bro from the future. Before you begin this topic, to work with random numbers, you may need to include this header file, ctime. Hey everybody, in this video I'm going to show you how we can generate some random numbers. Just so you know, these are pseudo-random numbers. They're not truly random, but they're close. Maybe if you need to roll a 6-sided dice for a game, well then this would work perfect. To generate some random numbers, we'll need to initialize the random number generator by typing srand and a set of parentheses, semicolon. Within the srand function, we'll need a seed. What programmers typically do is that they'll use the current calendar time as a seed. Within the parentheses, type time, parentheses again, then pass in null. I'll store the first random number within a variable, int num equals. To generate a random number, we invoke the rand function. Then I'll display this. Let's take a look to see what we have. Standard output num. Okay, the random number that we have is 3,231. Using the rand function, this will generate a random number between 0 and 32,767. But we don't necessarily need a number that large. I just need to roll a 6-sided dice. Well, what we're going to do is follow this with modulus, then the range of numbers we would like. If I'm rolling a 6-sided dice, I'll type modulus 6. Modulus gives you the remainder of any division. So take whatever number we roll, divide it by 6, take the remainder, and that's our number. But there's one issue with this. We have 5, 2, and 0. Technically, the range of numbers is currently 0 through 5. If we need 1 through 6, what we can do is add 1 plus 1. This should give us a random number between 1 and 6. There it is. 6. So I tend to play a lot of Dungeons & Dragons. There's polyhedral dice. One die that we commonly roll is a 20-sided dice. So if I would need a random number between 1 and 20, I would say rand function modulus 20. My random number is 1. Wow, that's surprisingly low. Then I have a 14. Maybe I need a random number between 1 and 100. Rand function modulus 100. My random number between 1 and 100 is 67. Now I need to roll 3 6-sided dice. I'm going to create 3 variables. Let's name this num1, rand function modulus 6 plus 1. Then let's copy this, paste it twice. We have num1, num2, num3. Let's display num1. I'll add a new line. Then do this 2 more times for num2 and num3. So our 3 dice that we're rolling are 5, 2, 2. Then again, 3, 1, 4. Yeah, everybody, that's how to generate some pseudo-random numbers. They're not truly random, but they're close. If you have a simple game you're working on, this would work perfect. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to generate some random numbers in C++. Hey everybody, in this topic we're going to create a random event generator using random numbers and switch. This might be useful maybe if you're writing a game. You need some random event to occur, like random monsters show up, or the weather changes, anything like that. We'll be working with random numbers. You may need to include this header file, include ctime, because we need access to the time function. To work with random numbers, we'll need to generate a seed. srand function, pass in time, pass in 0. This function will use the current time as a seed to generate random numbers. We'll create a local variable to store our random number. Int randnum equals, use the rand function, modulus. Then what's the range of numbers you would like? I would like the numbers 1 through 5. But this will give us 0 through 4, so I'm going to add 1 to the end. My integer random will be a random number between 1 and 5. I'm going to create a switch to examine this random number against many matching cases. So we have case 1 through 5. If the random number is 1, what would you like to do exactly? So in this program, I think we're going to give away prizes, like it's a random prize generator. Depending on the random number, we'll give a participant a random prize. Standard output, you win, how about a bumper sticker? A bumper sticker. That will be the lowest tier prize. Then we should probably add a break to break out the switch. Okay, let's think of some others. I should probably break after these. Prize 2 will be a t-shirt. Prize 3, how about a free lunch? Prize 4, maybe a gift card. Case 5, concert tickets. That sounds good. So when I run this program, we'll generate a random number between 1 and 5. Depending on what that number is, we'll execute the code found within one of these cases. Let's see what I want. I want a free lunch. If I try this again, there's a good chance it'll be a different prize. This time I want a bumper sticker. I want a bumper sticker again. Come on, I want those concert tickets. Yeah, I'll take a gift card. That's not bad. Now, if you don't add these break statements, you'll just fall through the switch. You want a gift card, or you want concert tickets. So if you only want somebody to win one prize, you'll want to exit out of the switch by including this break statement. So yeah, everybody, I thought that might be an interesting program. You can generate some random events. Maybe it's for a game or something. I thought maybe a random prize giveaway would kind of be interesting. This program is more or less for practice. Your assignment is to write a switch with some random events and post it in the comment section down below. And well, yeah, that's a random event generator using C++. Alright, welcome back everybody. In this video we're going to create a simple number guessing game. Let's declare our variables. Int num. Our number will be randomly generated. Int guess. This variable will hold the current player guess. Int tries. How many tries is it going to take for the user to guess the correct number? We'll be using the srand function to generate some random numbers. Pass in time. Pass in null. We will assign our variable num a random number between 1 and 100. Rand function, modulus 100, then add 1. This function will give us a random number between 1 and 100, store it within num. Just for some decorations, I'm going to create a setup for this game. Number guessing game. Then add a new line. I'll place all of this code within a do while loop. do while our guess does not equal num. We will have the user type in another guess. We'll create a prompt, standard output, enter a guess between 1 through 100. Standard input, guess. Once the user types in a guess, we will increment our tries variable by 1 to keep track of the score. Now we'll have to examine the guess versus the number. If guess is greater than num, let's display too high. I'll add a new one. Else if guess is less than num, then we'll display too low. Else, if the guess is not above the number and the guess is not below the number, the guess must be equal to the number. Standard output, correct. We'll display the number of tries. We'll display our tries variable. I'll add a new line. And I'll just add a line of text for decoration at the bottom once we exit the game. That should be everything. Let's run this. Number guessing game. I'll get something right in the middle. 50. Too low. Okay, so the number is between 50 and 100. I'll guess right in the middle of that range. 75. Too high. Something between 50 and 75. Perhaps 62. That's still too high. 56. Too high. 53. Too low. 54. 55. Alright, the correct guess was 55. It took me 7 tries. I don't really think that's too good, but it works. Okay, everybody, that is a simple number guessing game involving the use of do while loops and generating random numbers. If you'd like a copy of this code, I'll post this in the comment section down below. If you're enjoying the series, please let me know by smashing that like button, leave a rating comment down below, and subscribe if you'd like to become a fellow bro. Well, everybody, we have a pretty important lesson today. Today we're going to talk about functions. A function is a block of reusable code. If you ever think that you're going to use some section of code more than once, you might as well stick within a function. Here's an example. I'll create a function to sing happy birthday. Currently our program is within the main function. To begin the program, we call the main function. Before the main function, we can create a new function. For the time being, we're going to type void then a unique function name. The function name should be descriptive of what it does. If I'm going to sing happy birthday, let's name this function the happy birthday function. Then add a set of parentheses, then a set of curly braces. You can see that this is almost identical to our main function, except with the main function we have a return type and return 0. What would we like to do when we invoke this function? Let's sing some of the lyrics to happy birthday. Standard output. Happy birthday to you. Add a new line. Repeat this a couple times. Happy birthday, dear you. Happy birthday to you. To invoke this function, all we have to do is within the main function, type the function name followed by a set of parentheses. This will call, or otherwise known as, invoke the function. I like to think of the parentheses as a pair of telephones that are talking to each other. To use the function, you have to call the function, call it up on the phone. So when I run this code, we have the lyrics to happy birthday. This function is reusable. I can call this function as many times as I want. I'll call this function 2 additional times. Just to separate these lyrics, I'm going to add an additional new line character. Okay, we now should have 3 verses of happy birthday. 1, 2, 3. That's because I called the function, well, 3 times. A function is just a block of reusable code. Now, what a lot of people do is that they'll declare and define their functions after the main function because it's more readable to many people. But there's one issue with this. Happy birthday was not declared in this scope. Our programs are read from the top down. Since we're invoking the happy birthday function before we even know what it is, well, the compiler doesn't recognize it. A solution to this is that before the main function, you can declare functions, but define them later. Let's declare happy birthday before the main function. Then make sure you add a void or a return type. So void happy birthday. We can now use this function even though it's after the main function. A lot of people like to define their functions after the main function. It's another way in which you can write it. Just be sure to at least declare them before the main function. Now check this out. What if we have a variable? Standard string name. Assign this whatever your name is. I'm going to use this name that's declared in the main function and use it within the happy birthday function. Let's replace you with the user's name. Happy birthday to name. I'll add a new line. Then I'll copy this, paste it, and let's change this line as well. Alright, now when I run this, here's the issue. Name was not declared in the scope. Think of each function as a house. The main function is your house. Functions outside of the main function would be your neighbors, their house. Functions can't see what's going on inside of other functions. You can't see what's going on inside of your neighbor's house. You're only familiar with what's going on inside of your own house. In order for the happy birthday function to use the main function's name variable, it needs to be made aware of it. To do that, when you invoke a neighboring function, you can pass that variable or some other value as an argument. So within the parentheses, when you invoke that function, place your values or variables. I would like to make my happy birthday function aware of this name variable within the main function. When you send some data over to a function, that data is also known as an argument. However, the receiving function needs a matching set of what are called parameters. If this function is going to receive this data, this name, you need a matching parameter. To set up the parameter, you first list the data type. We will receive a standard string, then we can list a parameter name. Let's say name. Now this happy birthday function can use this name variable within the main function. If you have a function declaration at the top of your program, you'll have to add that parameter there as well. So happy birthday, standard string, and we can run this. Happy birthday to whatever your name is. Functions aren't aware of what's going on inside of other functions, but you can make them aware of any local variables or values by passing them as an argument, but you'll need a matching set of parameters. The name or otherwise unique identifier of your parameter doesn't necessarily need to have the same name, so to say. You can name it something else. Instead of naming our parameter name, let's say birthday boy or birthday girl. Happy birthday to birthday boy. And that should work the same. So you can rename parameters. Well, let's revert that back. Now let's pass an age. Int age equals, make up some age. I would like to send my age over to the happy birthday function. So I will pass that as an additional argument. Separate each argument with a comma. We'll send our name as well as age. Now we need a matching set of parameters. Right now the happy birthday function is only equipped to receive a name. So we list the data type, int age, and if you have a function declaration, change that there as well. Then I'll add one more line. You are age years old. Then this should work. Okay, happy birthday to whatever your name is. You are, whatever your age is, years old. So that's the function, everybody. It's a block of reusable code. If you think you're going to perform some code more than once, you can stick it within a function. Whenever you need it, you just simply call it. If you need to make your function aware of any variables, you can send them as arguments to that function, but you'll need a matching set of parameters in the function definition and the declaration. So yeah, those are functions, everybody. Your assignment is to create a unique function and post it in the comment section. And well, yeah, those are functions in C++. Alright, everybody, we are on the return keyword. The return keyword will return a value back to the spot where you called the encompassing function. The return keyword is commonly found at the end of a function, much like the main function. When we invoke a function, we can return some value back. Here's an example. I'll create a function that will calculate the area of a square, but we'll need to pass in a length, the length of one side. This will be a double length, assign some value. 5.0 is good. Then we'll need to declare and define a function. At the top of my program, I'll add a function declaration. For the time being, we'll write void, but that will change soon. Void, I'll name this function square. We will square a length, list any parameters. We will accept a double value, which we will name length. Then I'll need a function definition. I'll add that after the main function. Void square. I'm going to create a temporary variable named result. It will be of the double data type. We will take length times length to calculate the area. Then I will use that return keyword. Return whatever you're returning. We're returning a result. If we're returning a value, we need to change this keyword void to match the data type of what we're returning. We're returning a double, so I will change void to double. And then make sure you change that within the function declaration as well. Double square. You could do this in one line of code. You don't necessarily need to. We could simply just return length times length. That is also valid. That's probably how I would write it. We now have this function that will calculate the area of a square once we pass in a length. I'm going to create a new variable called area. It will be of the double data type, and I will set this equal to. Then let's invoke the square function. Pass in our length variable as an argument. At this point in the program, an area should be assigned a value. Let's display it. Standard output area. I'll add my area variable. Then add centimeters squared, mending line. The area of our square is 25 centimeters squared. And I could change this to a different number, like 6. The area is now 36 centimeters squared. Let's create another function. This function will find the volume of a cube if we know the length of a slide. We'll return a value of the double data type, but I will name this cube. We will still accept the length of the double data type. Let's copy this, paste it, change square to cube, return length times length times length. Double volume equals, we'll invoke our cube function, pass in our length, then I will display whatever the volume is. Volume, my volume variable, centimeters cubed. If the side of the square is 6 centimeters, the area would be 36. If it was a cube, the volume would be 268 centimeters. If you need to return a value back to the spot in which you invoked the function, be sure to list the data type of what you're returning. Let's try another example involving strings. I'll create a function that will add a user's first name, their last name, and create a new string called full name. Let's declare our variables. Standard string, first name equals add your first name. Standard string, last name equals add your last name. Then I'll create a function to concatenate two strings together. We're returning a string. I will list the data type as standard string. I'll name this function concat strings. We will have two arguments, two standard strings. Standard string, I'll name the first string string 1. Standard string, string, misspelled string, string 2. So we have our function declaration. Now we just need to define it. I'm going to return string 1 plus, I'll add a space between the first name and the last name, plus string 2. I'll create a third variable, standard string, full name equals, I will invoke my concat strings function. Then I need to pass in 2 strings as arguments. I'll pass in my first name and my last name. Then let's display the full name. Standard output, hello, the user's full name. Hello, bro code, or whatever your first and last name is. So yeah, everybody, that is the return keyword. Wherever you invoke a function, you can return a value back to that spot in which you invoked that function. If you're returning a value, just be sure that you change the return type of that function to match the data type of the value being returned. In this example, I returned a string, a standard string. So the return type of this function would be a standard string. So that's the return keyword, everybody. Your assignment is in the comment section to post a function that returns some value. So yeah, that is the return keyword in C++. Hey guys, in this topic I'm going to explain overloaded functions. In C++, and actually with many other programming languages, you can have different versions of the same function. Here's what I mean. I have a function to bake a pizza because, well, I like pizza. Bake pizza. This function will have no parameters. All I'm going to do within this function is display the words, here is your pizza. Then I'll add a new line. Then I should probably add a declaration at the top. Void bake pizza. Then to invoke this function, I will type the function name. Here is your pizza. This time I would like to bake a pizza that has toppings. Right now we just have a plain pizza with no toppings, and that's kind of lame. I'm going to create an additional version of this baked pizza method, but it's going to have different parameters. Void bake pizza. We will accept a string. Standard string. I'll name the string topping 1. We'll accept 1 topping as an argument. Standard output. Here is your, I'll add my topping here. Topping 1. Pizza. Then be sure to add your function declaration too. Bake pizza. Then this time we are accepting a string. It is valid for functions to share the same name, but you need a different set of parameters. A function's name plus its parameters is known as a function signature. I can bake a pizza that has no toppings. Here is your pizza. Or I could pass in a topping like pepperoni. Here is your pepperoni pizza. Let's create an additional function that accepts 2 toppings. So we have topping 1, topping 2. Here is your topping 1 and topping 2 pizza. Then add your function declaration. Topping 1, topping 2. Now I can bake a pizza that has 2 toppings. I would like pepperoni and mushrooms. Here is your pepperoni and mushroom pizza. So yeah, everybody, those are overloaded functions. Functions can share the same name, but you need a different set of parameters. A function's name plus its parameters is known as a function's signature, and each function signature needs to be unique, kind of like an ID. So yeah, those are overloaded functions. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, those are overloaded functions in C++. Okay, everybody, we got to discuss variable scope. I'll explain local variables and global variables. Local variables are declared inside of a function or block of curly braces, such as within the main function or inside of another function. Global variables are declared outside of all functions. You tend to see them at the top of your program. They There's some major differences between the two. Let's begin with local variables. Suppose I have some number, int mynum. mynum equals 1. If I need to display mynum, I can use standard output mynum. And of course, this will display mynum, which is 1. Now what if I have a function to display mynum? Void print num. Let's move this line of code into our print num function. I'll need to add a function declaration to the top of my program. Then we will invoke this function, print num. Okay, this isn't going to work, and here's why. mynum was not declared in this scope. Functions can't see inside of other functions. My function print num has no idea what this mynum variable is. mynum is a local variable to the main function. That's why we pass arguments to functions. We'll make the function aware of this value, but it'll need a matching set of parameters. Int mynum, then add that to the function declaration, int mynum. And this would work. That displays the number 1, but let's get rid of these parameters. It is legal to reuse the same variable name as long as it's within a different scope. Within the printNum function, I'll also have a mynum variable that has the same name, but I'll give this a different value. When printing mynum, it prints 2. We have 2 versions of the same variable, and this is fine because they're within different scopes. Now, a global variable is declared outside of all functions. You see these at the top of your program. I will declare int mynum equals 3. I'm going to delete these 2 local variables. If I was to invoke the printNum function and print mynum, well then, that number is 3. This global variable is also available within the main function, so I will print mynum here as well within the main function. So we have 3 and 3. It's best to avoid the global variables if you can, because it pollutes the global namespace. Also, variables declared within a function are much more secure, because like I said, functions can't see inside of other functions. If we had both local and global variables, mynum within the main function will be 1. Within the printNum function, it will be 2. If I was to display mynum for both of these, I'm going to add a new line to each of these. New line, and new line. A function will use any local variables first, before resorting to any global variables. That's why our printNum function prints 2, and the main function prints 1. If you'd rather use the global version, you can use the scope resolution operator. So precede your variable name with 2 colons. That is the scope resolution operator. I'll do that here as well. In place of using the local version of mynum, we will use the global version. And we will print 3. We're using the global version of mynum instead of the local version. So yeah, that's variable scope. Local variables are declared inside of a function, or anytime you see a set of curly braces. A variable declared inside a set of curly braces is hidden to the outside world. A global variable is declared outside of all functions, and is accessible to all functions within the program. Like I said, you should try and avoid using global variables if you can, because it pollutes the global namespace, and these variables are less secure. So yeah, that's variable scope. Hey, if you're enjoying the series, let me know by smashing that like button, leave a random comment down below, and subscribe if you'd like to become a fellow pro. Hey guys, in this topic we're going to create a banking program for practice. We'll be able to deposit money, withdraw money, and show a balance. This is more or less just for practice. Let's begin by creating our functions. Void show balance. There will be one parameter, double balance. Whatever our bank account balance is, we'll show it. The return type is double deposit. No parameters. Double withdraw, and there will be one parameter, double balance. Let's fill in a few things within the main function. Double balance, and I will go ahead and set this to 0, as well as int choice. I will set that to 0 as well. We'll use a switch to determine if the user wants to show their balance, make a deposit, display some output, some prompts. Standard output, enter your choice. And I'm just going to add some text decorations because I think that'll be cool. Maybe a bunch of asterisks. And one more. Okay, we have option 1. 1, show balance. 2 will be deposit money. 3 is withdraw money. 4 will be exit. 5 will accept some user input. Standard input choice. Now we're going to create a switch. We're examining the user's choice. Switch. We're examining our choice against many matching cases. We have case 1, case 2, 3, 4, and then a default case. Okay, case 1. The user wants to show their balance. We'll invoke the show balance function, but we need to pass in our balance. Balance, and then we are going to break. Case 2, the user wants to deposit money. So we're going to take our balance equals balance plus our deposit function. So deposit will return a double right here. So we're going to add that to our balance once we verify it. Actually, we can shorten this to balance plus equals whatever value is returned with the deposit function. Then we are going to break. Case 3, withdraw money. Balance minus equals the withdraw function, pass in our balance. We're withdrawing money from our balance once we verify it. Then we're going to break. We'll exit with case 4. I'll display some output. Standard output. Thanks for visiting. Then I'm going to break. Okay, default case. Standard output. Invalid choice. Okay, now we're going to place all of this code within a do-while loop. Do all of this while some condition is true. So let's take all of this code, cut it, put it within that do-while loop. Let me just format this a little bit. The condition will be while choice does not equal 4. 4 is what we use to exit. We'll need to add some function definitions, but I'm going to fill these in later. We'll need to return something, so let's return 0 for the time being. For 2 of these functions at least. Return 0. Okay, let's run and compile this just to test our do-while loop. Okay, as your choice. 1, show balance. That doesn't show our balance yet, but it will. Deposit money, withdraw. Now we should be able to actually by pressing 4. Thanks for visiting. Okay, so we know that the do-while loop is working. Let's fill in our functions. Let's begin with show balance. Now with the show balance function, we're receiving our balance as an argument. So I'm going to display standard output. Your balance is $, or some other currency that you choose. I'll display our balance, then add a new line. So let's say we have $123 in our account. I'm going to show my balance, $123 even. But I would like to display cents. I'll need 2 decimal places after the decimal. So there's one thing we can include. We'll include this header file. Include repeat, there's a function in here to set some precision for floating point numbers. I'm going to make this change after the $sign. Standard set precision passed into for 2 decimal places. Then add standard fixed. This will display our balance up to 2 decimal places after the decimal point. So let's try that again. Okay, show balance $123.00. I already changed this to 123.01. We should display 2 decimal places. Yeah, $123.01. Okay, that is the show balance function. Let's work on the deposit function. Okay, now we're within the deposit function. I'm going to create a local variable named amount. Set this equal to 0. We'll ask the user how much they would like to deposit. Standard output. Enter amount to be deposited. Standard input our amount. So I'm going to set balance back to 0. And then let's test it. Show balance 1. Your balance is $0.00. I would like to make a deposit of $420.69. Okay, now I would like to show my balance after we make a deposit. So within case 2, after making a deposit, let's show our balance, pass in the balance variable. Now let's do so after withdrawal too. Okay, let's try that again. Show balance, $0.00, make a deposit, $420.69. Your balance is $0.00. So what we're going to do is return our amount at the end of this function. Return amount, $420.69. Alright, we have our balance. The user is able to enter in negative money. Enter amount to be deposited, -$1,000. Your balance is now -$1,000. We need to prevent somebody from making a negative deposit. So before we return our amount, let's use an if statement. If amount is greater than 0, then we will return the amount. Else, standard output, that's not a valid amount. Then let's return 0. Okay, let's try it again. Deposit money, -$1,000. That's not a valid amount. Your balance is $0. I'm just going to add a new line, like right here. Then let's make a legitimate deposit. Deposit money. I will deposit $1,000.01. Your balance is $1,000.01. Okay, that is the deposit function. That is complete. Then we have the withdraw function. We'll create a local variable named amount of the double data type. We'll create a prompt, standard output. Enter amount to be withdrawn. Standard input. Amount. At the end of this program, we will return amount. Okay, let's test it. Okay, I need to deposit some money first. I will deposit $1,000.01. Then let's withdraw money. I will withdraw $100.01. My new balance is $900, but we can overdraw our account still. So I'm going to withdraw $1 million. And what's that? Our balance shouldn't be negative, so let's prevent our user from overdrafting their account. Within our withdraw function, let's add an if statement. If amount is greater than our balance, we'll display insufficient funds. Then we will return 0. to deposit negative money. Withdraw money, negative 1,000. Your balance is $1,000. We'll need to make sure that the amount is a legitimate amount. I'll add an else if statement. If amount is less than 0, standard output, that's not a valid amount. Now, else, we will return the amount to be withdrawn. Then within the else if statement, we'll need to return 0. There. Okay, let's withdraw money. Enter amount to be withdrawn, negative $1,000. That's not a valid amount. That's good. Let's withdraw again. I would like to withdraw $100. Insufficient funds. My balance is 0. Let's deposit some money. $99.99. Our balance is $99.99. Let's withdraw again. Let's try and withdraw $100. Nope, we can't. Let's withdraw again. $99.99. Your balance is 0. That's good. Now let's exit. Press 4 to exit. Thanks for visiting. Okay, so these functions are done. There's just one more thing we should add. If I type in some characters like the word pizza, well, this will break our program. We'll want to clear the input buffer. So after our choice, let's have these two lines. Standard input dot clear function. So I've been talking about this function. This function will reset any error flags when the standard input fails to interpret the input. Then follow this with f flush. This is a function passed in standard input. This will clear the input buffer. Basically speaking, once we've entered, we have a new line character within our input buffer, so we just need to flush that and get rid of it. That should prevent our program from going crazy. So let's type in some characters. Invalid choice. Cool. Then I would like to exit. Alright everybody, that is a thinking program for some practice. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a thinking practice program in C++. Alright everybody, in this video we're going to create a game of rock, paper, scissors. Let's create our function declarations first. Char get user choice. Char in this case would be the return type. We'll be returning a character. Char get computer choice. Void, there is no return type. Show choice. There will be one parameter. Char choice. Then the last function is void choose winner. There will be two parameters. Char player, that's us. Char computer. The computer's choice will be determined randomly using a random number generator. Let's define these functions. Let's copy all of these. After the main function, I will paste them, then add a set of curly braces after each. Currently, if I were to run this program, we do have some warnings because with these two functions, get user choice and get computer choice, we're not returning anything, even though we stated that we're returning a character. Just for the time being, I'm going to return 0, just so that those warnings go away. But we'll correct these momentarily. So we shouldn't have those warnings. Within the main function, we will declare two characters. One for player, char player, that's us. Char computer, that's the opponent. We will take our player, then assign this a value of whatever is returned from the get user choice function. Then we need to fill in this function. Within the get user choice function, I will create a local variable of player as well. I'll create a message to begin our game. Standard output, rock, paper, scissors, game. I'll add a new line. This part isn't necessary, but I'm just going to add a bunch of asterisks afterward. Just because but I think it would look cool underneath our title. Let's list our choices. Standard output, the character R for rock. New line. Let's copy this. P for paper. S for scissors. Standard input, player. I'm just going to test that this works. Standard output, player. Rock, paper, scissors game. R for rock, P for paper, S for scissors. I'll pick R. That would give us the character R. Okay, so we know that that works. I'm going to place some of this code within a do while loop because the user might not type in R, P, or S. So, do while. I'm going to stick my code within the do while loop. And I'm just going to add one more line of output. Choose one of the following. Alright, we'll continue this while loop as long as our player does not equal the character R and player does not equal the character P and player does not equal the character S. Then at the end of this function, we will return player. We can't escape this while loop until we pick either R, P, or S. That's how this condition works. Let's test it. Rock, paper, scissors game. Choose one of the following. R for rock, P for paper, S for scissors. I will pick W for wombo. Choose one of the following. R, P, or S. I like the letter X. Nope, can't pick that. Let's go with S for scissors. Okay, S is a valid choice. Okay, that is the get user choice function. That's complete. So I'm going to close out of this function. After we assign our player variable, let's display the user's choice. Standard output your choice, :space. Then we will invoke the show choice function. Show choice. Then there is one parameter. We have to pass in a choice as an argument. We will pass in our player. That's a character. Within the show choice function, I'm going to create a switch. Switch. We're examining some value against matching cases. We'll examine our choice argument that we receive. If our choice matches the case R, what would we like to do? I'm going to display some output. Standard output, just rock. Then I'll add a new line. Make sure to break. And then case P for paper. Standard output, paper. I'll add a new line. Then break. Case S for scissors. Standard output. Scissors. New line. Then break. Let's close out of this function, then test it. Okay, I'll type R for rock. Your choice, rock. P for paper. Your choice, paper. S for scissors. Your choice, scissors. Okay, the show choice function is done. Now we need to get the computer choice. Computer equals computer choice. Then we'll need to fill in this function. Get computer choice right here. We'll need to generate a random seed. As rand, pass in the time function, then times 0 or null. You may need to include this header file at the top of your program, just in case this doesn't work. Include seed time. We'll generate a random number between 1 and 3. And num equals rand function modulus 3 plus 1. We'll examine this number against matching cases. Switch. We're examining our num. The first case will be the number 1. If our random number is 1, let's return the character R. Since we're returning a value, we don't necessarily need to add that break statement. We're already breaking when we return. So we can omit this. Case 2, return the character P for paper. Case 3, return S for scissors. Okay, we can close out of the getComputerChoice function. That's all done. Back within the main function, let's display the computer's choice. Standard output, computer's choice. We'll invoke the showChoice function. Let's pass in our computer. Let's run it to test it. I'll pick R for rock, your choice rock, the computer's choice is paper. Let's try it like 2 more times. Okay, we chose paper, the computer chose rock. Let's pick S for scissors. Your choice scissors, the computer's choice is also scissors. Okay, so the computer is picking a random choice, and that's good. Now we'll have to decide who won. At the end of our program, we will invoke the chooseWinner function, pass in our player, as well as the computer. Then within the chooseWinner function, let's create another switch. We will examine our player against matching cases. If our player chooses rock, the character R, I think the best way to do this would be to use if statements within each case. If the player chooses rock, and if the computer chooses R for rock, that means there's a tie. I'll display that. Standard output, it's a tie. Then I'll add a new line. Else if the computer chooses paper, that means we lose. Standard output, you lose. Else, well, there's only one option left, scissors, because if the computer didn't choose rock or paper, that means they picked scissors. Rock beats scissors, so let's display that the user won. You win. Oh, then be sure to add a break at the end to break out of the switch. This is the case if the player chooses rock. Let's copy all of this code. Paste it. And let's move this over. Now if the user chooses paper, we have some different results. Paper beats rock. We'll change this line of output to be you win. If the user chooses paper and the computer chooses paper, that means it's a tie. It's a tie. If we choose paper and the computer chooses scissors, that means we lose. You lose. One more case. If the player picks scissors and the computer picks rock, you lose. Scissors beats paper, you win. Else, scissors ties with scissors. It's a tie. And that is everything. So let's close this function and run this program. Okay, I'll pick R for rock. We picked rock, the computer picked scissors, you win. P for paper. The computer also picks paper, it's a tie. I'll pick scissors. I picked scissors, the computer picked rock, you lose. Well, alright then everybody, that is a game of rock, paper, scissors. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a game of rock, paper, scissors in C++. We have a big topic today. I need to discuss arrays. An array is a data structure that can hold multiple values. Values are accessed by an index number. Think of an array as kind of like a variable that holds multiple values. It's a little more complicated than that, but that's a good way of thinking about them. Perhaps we have the name of a car. This will be a standard string. I will name this car. Assign this a value of whatever car that you like. One car that I like is a Corvette. Then I will display whatever our car is. Standard output, car. So of course this car is a Corvette. We can transform this variable into an array by making the following changes. After the variable name, add a set of square brackets. Then enclose your values with a set of curly braces. There, we now have an array. My variable car is now an array. Now this variable can hold multiple values, multiple cars, kind of like its parking garage. Separate each value with a comma. This time I'll add a Mustang, then a Camry. Now take a look at this. I will display car. Now what the heck is this? So this is a memory address of where our array is located, like 123 Fake Street. If I need one of these elements, one of these values that's found within the array, in order to access it, I have to do so by an index number. After the array name, I will add a set of square brackets, then an index number. The first element in an array has an index of 0 because computers always start with 0. And we have our Corvette. It's kind of like a parking spot number. That's why I went with this example of cars. Finding the next element within my array, I would access element number 1. Then I should probably add a new line, just to separate these. New line. We have our Corvette and our Mustang. Then we have our third element, which would have an index of 2. So we have our 3 elements, our Corvette, our Mustang, and our Camry. You can reassign values too. I'm going to change the first element within this array. Take the array name, select an index number. I'll set this equal to a Camaro, a Chevy Camaro. Now at parking spot number 0, we have our Camaro, then our Mustang, then our Camry. I'm going to rename car as cars, just so people know that it's plural, although it's not necessary. One thing with arrays is that they can only contain values of the same data type. Like I'll try and stick a number within here. Number 1. So our compiler doesn't like it that there's a number in here with all these strings. So arrays should all be of the same data type. Now if you don't know what you want to place within an array, you can simply declare an array and then assign values later. I'm going to declare an array of cars, and then later assign some values. Cars at index 1 will have our Mustang. Cars at index 2 will be our Camry. So we still have an error though. Array finds missing in cars. You can declare an array, then assign values later. We need to set a size to this array. It's a static data structure. If I'm only going to place 3 cars within this array, I'll set the size to be 3. So within the square brackets, you can set an array size. And this would work the same. You can declare an array, be sure to set the size, and then assign values later. Let's try one last example. I'm going to create an array of prices. These will be of the double data type. Prices, add a set of square brackets. I'll go ahead and assign its values right away so I don't need to declare a size explicitly. Make up some prices. $5, $7.50, $9.99, then $15. I'll display these prices, standard output, prices. I'll list an index number of what element I'm trying to access. The first would be 0. Then I'll add a new line. Let's copy this line of code and paste it a couple more times. We have prices at index 0. That is the first element. Then 1, 2, and 3. And here are the prices. So yeah, that's an array. Think of it as a variable that can hold multiple values. It's a little more complicated than that. It's a type of data structure, but that's a good way of thinking about them. To change a variable into an array, after the variable name, add a set of square brackets, place your values within a set of curly braces. That's if you're assigning values right away. Or otherwise, you can set a size, and then assign values later. That's another option. So yeah, those are arrays. Your assignment is to post an array in the comment section down below. And well, yeah, those are arrays in C++. You guys ready? Alright, let's talk about the size of operator. The size of operator determines the size in bytes of a variable, data type, class, object, etc. Whatever you would like to find the size of, you stick within the parentheses of the size of operator. Here's an example. Let's create a double GPA. Our GPA will be a solid 2.5. To determine the size in bytes of my variable or a data type, I will just place within the set of parentheses. I'll display this. Standard output size of operator. I would like to return the size of my GPA variable. Then I'll just add a string. Bytes. New line. Let's take a look. The size of my GPA variable is 8 bytes. That's the maximum size allocated to my double variable. If I was to replace GPA with a data type, such as double, well, this would be the same, 8 bytes. This will be helpful in the future when we begin working with arrays. So let's try a couple other variables. I'll create a string, standard string name. Assign some name. Then I will find the size of the string. Size of name. The size of a string is 32 bytes. Because a string really just holds an address to where some text is located. The address of where the string of text is located is 32 bytes. Even if I were to change the size of the string, bro code is awesome. Well, this size is still going to be the same, 32 bytes. Because a string is a reference data type. Let's try a couple other examples. How about a character? Char grade. My grade will be an F. I will find the size of this character grade. The size of the character is 1 byte. Let's try a Boolean. Boolean student. Is somebody a student, true or false? I'll place student within the size of operator. A Boolean variable also takes 1 byte of memory. This time, let's find the size of an array in bytes. I'll create an array of characters. Char grades. This will be an array. I'll set this equal to some grades. A, B, C, D, then F. I'll place my array within the size of operator. The size of this array, grades, is 5 bytes. Remember that characters take up 1 byte of memory. An array of 5 characters would be, well, 5 bytes. We can use the size of operator to calculate how many elements are within an array. If we have the total size of our array, we could divide this by the size of one element. Size of grades at index of 0, or otherwise we can find the data type. We'll divide the size of my array grades divided by the size of the character. So I should have these many elements. 5 elements within my array of grades. If I were to add one more grade, like an E, even though that's not a typical grade, well then the total elements within that array would be 6 elements. That's a useful trick to calculate the size of an array, how many elements are within that array. One more, this will be a bonus question. I'll create an array of strings. I'll name this students. we'll enter in some student names, such as SpongeBob, Patrick, then Squidward. To calculate how many strings are within this array, how many students we have, we can find the size of my array students divided by the size of a string. I have 3 elements within this array of students. Then I could add one more. And this equation should calculate that. I'll add Sandy. Size of students divided by the size of a string would give me 4 elements. So yeah, that's the size of operator, everybody. It will return the size in bytes of a variable, data type, class objects, all sorts of things. It will be really helpful when working with arrays because we can determine the size of an array. But we'll get some practice with that in the future. And well, yeah, that's the size of operator in C++. Alright guys, in this video I'm going to show you how we can iterate over the elements of an array. Suppose we have an array of students. These will be strings. Standard string. I'll name this array students. Set this equal to some student names. Pick a few. SpongeBob, Patrick, then Squidward. Suppose I would like to display all these students. Normally to do that I would type standard output my array followed by an index number. So the first student would be SpongeBob, which has an index of 0, and my first student is SpongeBob. If I need to display all of the elements of this array, I would have to one by one access each element. Then I'll just add a new line. We have SpongeBob, Patrick, and Squidward. If I need to display all of the elements of an array, a better approach would be to use a for loop. I'm going to type for, parentheses, curly braces, we'll need an index, int I. I'll set this equal to 0 because the first element in our array has an index of 0. I'll continue this as long as I is less than the length of our array. Currently it's 3. Then increment I by 1. During each iteration, I would like to display each element. Standard output students. Now instead of an index number like 0, 1, 2, whatever, I'm going to use my counter variable I. Students have index of I. During the first iteration, I will be 0, then 1, then 2. Once we reach 3, we'll stop. I'll add a new line. This for loop will print the elements of my array. SpongeBob, Patrick, Squidward. There's one issue with this though. What if we add another student, such as Sandy? Well, this for loop will stop once I reaches 3. If we make any adjustments to this array, we would have to go into our code and make some changes, such as setting this for loop so that we discontinue when I reaches 4. This would work, but it's not the best solution. For our stopping condition, in place of just setting I to be less than some number, let's calculate how many elements are within this array. To do that, we can use the size of operator. I'll type size of my array. This will give me the total size in bytes of my array. To calculate the number of elements, I can divide size of students by the size of the data type, string, or even an element. This will loop through all of the elements of this array, SpongeBob, Patrick, Squidward, Sandy. If we change the number of elements, well then there's no need to touch this for loop. It will calculate the size automatically. See, now we just have SpongeBob and Patrick. Let's create one last example. I'll create an array of grades. Char grades. We have an A, B, C, D, then F. If I need to iterate over this array of characters, I would find the size of my array, grades, divided by the size of a character data type. During each iteration, I will display grades at index of I, our counter. And this will display all of the elements of this array. So yeah, that's how to iterate over an array using a for loop. In the next topic, I will explain the for each loop, which has different syntax. And well, yeah, that's how to iterate over an array using a for loop in C++. Alright guys, the for each loop. The for each loop is a loop that eases the traversal over an iterable dataset. An array is an example of an iterable dataset. Suppose we're using a standard for loop, and I have this array of strings named students. We have SpongeBob, Patrick, and Squidward. Using a standard for loop, I would need three statements: an index, a condition, then we could increment or decrement our index. This does work, but there is another way of writing this using a for each loop. There is less syntax than a typical for loop, but it's less flexible. Using a for loop, we can go forwards, backwards, or even skip iterations of something we're iterating over. Using a for each loop, we start at the beginning and go to the end. There's less flexibility. So let's change this to a for each loop. First, we'll add the data type of what we're iterating over. We're iterating over strings. Then we'll need a name for the current element that we're on. We have an array of students. Let's name the current element student, colon, then our iterable dataset, which would be our array. String student, colon, students. During each iteration, let's display whatever the current element is, which I named student. Then I'll add a new line. And there we go, we have our three students. Then you could change the amount of students if you would like. Let's add Sandy. Now we have SpongeBob, Patrick, Squidward, Sandy. Let's try a different example. Let's work with grades this time. These will be of the int data type. Int grades equals, make up some grades. 65, 72, 81, 93, good enough. The data type of what we're iterating over is not a string this time. It is an int, integers. Let's name each element simply grade, colon, the name of my iterable dataset, which would be my array, grades. For every grade in grades, let's display each grade. And here are the grades, 65, 72, 81, 93. So that's a for each loop. It's a loop that eases the traversal over an iterable dataset. There's less syntax involved in a for each loop, but it's less flexible. If you just need to display the elements of an array, a for each loop would work perfect. So yeah, that's a for each loop, everybody. Your assignment is to post a for each loop in the comment section down below. And well, yeah, that's the for each loop in C++. Alright everybody, so in this video I'm going to show you how we can pass an array to a function. Suppose we have an array of prices. These will be of the double data type. Double prices, straight brackets, equals, just make up some prices. $49.99, $15.05, $75, $9.99. Good enough. We'll create a function to find the sum of these prices and print the total. Let's say double total equals, then I'll invoke a get total function, which we still need to declare and define. So let's do that now. We'll return a double get total. Let's list the parameters. We need to accept an array of doubles, double prices, then add a set of square brackets for the parameter. Now when we pass an array to a function, you only need to pass the array name. You don't need a set of square brackets. Then we'll need a function declaration. Let's do that before the main function. Then at the end of my program, I will display the total. Standard output. Pick a currency. Let's pick a $sign. Then I will display the total. Within the getTotal function, I'm going to declare a separate local instance of a total variable. Remember that variables can have the same name as long as they're within a different function. So we have double total. I'm going to iterate over my array using a for loop. Normally what we would do is say int I equals 0. I would continue this as long as I is less than. Then at this point we would calculate the size of the array. But technically this isn't going to work, and I'll demonstrate why. We have the size of our array, prices, divided by the size of either the data type or one of the elements. Typically I like to use one of the elements. Prices at index 0, then I will increment our counter by 1 during each iteration. Within our for loop, let's assign total equal to total plus prices at index of I. Or we could shorten this to total plus equals prices at index of I. At the end of our program, we will return whatever the total is. Now, this isn't going to work the way it's written now. Here's why. When we pass an array to a function, it decays into what's known as a pointer, which we haven't discussed yet, but we will in future topics. Within this function, we're not working with an array anymore, we're working with a pointer that points to the address of where the array begins. This function has no idea how big this array is anymore. We can't calculate how many elements are within this array. What we could do is that when we invoke this function, we can pass in the array as well as the size of the array. Since this function no longer knows how big the array is, we can explicitly let the function know what the size is. So let's calculate what the size is. Int size equals, we can just copy all this code, paste it. Now when we invoke this function, I'm going to pass the size as a second argument. Then we'll need a matching set of parameters. Int size, be sure to add that with your function declaration too if you have one. I would like to continue this for loop as long as I is less than size. Now this should work. Let's verify that. Yeah, and our total is $150.03. In conclusion, when you pass an array to a function, you only have to pass the array name. You don't need a set of square brackets when you do so. However, when a function receives an array, it decays into a pointer, and the function no longer knows what the size of the array is. So we could pass that as an additional argument to let the function know what the size is, which we could then use to, iterate over the array. So that's how to pass an array to a function. Your assignment is to post a function that accepts an array as an argument in the comments section down below. And well, yeah, that's how to pass an array to a function in C++. Hey, welcome back. So in this video, I'm going to show you how we can search an array for an element. Let's create an array of numbers. Something simple. Int numbers. This will be an array. Then assign some numbers. I'll just assign the numbers 1 through 10 because I'm basic like that. There, 1 through 10. We'll probably need this later. I'm going to calculate the size of the array. Int size equals size of my array numbers divided by the size of one of the elements. I'll just take the first element. We'll need to keep track of an index, like what index did we find something that we're searching for. Int index. I'll declare this variable, but we don't need to assign it. As well as int my num. My num will be the number that we're looking for. Let's accept some user input. We'll create a prompt. Standard output. Enter element to search for. We'll add a new line because I can. Standard input my num. I'm going to create a function that will search an array for us. Let's define that function outside of the main function. This function will return an integer. That will be our index. The return type is int. I'll name this function search array. There's a couple of parameters. We'll have 3 parameters. An array of integers, integer, array, the size of the array, int size, then some elements that we're searching for. Int element. Then we should probably add a function declaration at the top. That's good. This function will return an integer, the index of the elements that we're searching for. We will take our index variable, set this equal to, then I'm going to invoke the search array function that we just declared, but we need pass in our array numbers, the size of the array that we already calculated, and the elements that we're searching for. We're searching for mynum. Within the search array function, we will iterate from the beginning of the array to the end and see if there's any matches. We can do that with the for loop. We'll begin at 0. Int I equals 0. That's our index. I will continue this as long as I is less than the size of the array that we're passing in as an argument. Then increment our index by 1. This would be technically a linear search. We'll start at the beginning and check every value until we reach the end. So let's check using an if statement within the for loop. If our array, we did name this array numbers, but remember that you can rename parameters. Numbers is technically our array. If our array that we receive at index of I, that's our counter, is equal to the element that we're searching for, we will return whatever the index is, I. If we search through this entire array and don't find that element that we're searching for, we'll return -1. In programming, -1 serves as a sentinel value. If you see -1, that typically means that something wasn't found. We'll return either I or -1. Then assign it to this index variable within the main function. Using this statement, we'll check to see what that value is. If our index does not equal -1, that means the element that we're searching for is somewhere within our array. Let's display the index. Standard output mynum is at index, whatever the index variable is. Else, standard output mynum is not in the array. Okay, let's see if this actually works. Enter elements to search for. Let's search for 1. 1 is at index 0. Remember that computers always start with 0. Enter an element to search for. Let's search for 10. 10 is at index 9. Enter an element to search for. 420, 69. 420, 69 is not in the array. For additional practice, let's search through an array of strings, such as food. We'll create an array of strings. I'll rename numbers as foods. Then think of some food that you like. Pizza, hamburger, hot dog. Int size equals the size of foods divided by one of the elements of foods. Let's rename mynum as myfood. That's the food that we're searching for. And that will be the string data type. In place of cin when working with strings, let's use getLine because the user input may contain spaces. Standard getLine standard input myfood. Within the search array function that we created, we will pass our array foods. The size can stay the same. Then pass in myfood, and that's what we're searching for. Within the if else statements, replace mynum with myfood. Then we'll need to change the data types of this function. We're accepting an array of strings. Replace int with string. Do that with your element as well. Then we need to change the function declaration at the top of our program. Okay, we can now search through an array of strings. Enter element to search for. Let's search for pizza. Pizza is at index 0. Hamburger. Hamburger is at index 1. Hot dog. Hot dog is at index 2. Then let's search for something that's not within this array. What about sushi? Sushi is not in the array. Yeah, everybody, that is how to search through an array. This would technically be a linear search. You begin at the first element of an array, check to see if the values are equal. If they're not equal, you move to the next search through an array in C++. Hey everybody, in this topic I'm going to show you how we can sort an array. First I'll explain the logic behind it, then we'll write a C++ program to actually handle it. We'll use a standard bubble sort. It's an easy sorting algorithm to write, although there are more efficient sorting algorithms. We're still learning, so let's stick with a bubble sort. So with the bubble sort, we begin at index 0, the beginning of our array. We'll examine the elements directly to the right. If the element on the left is larger than the element on the right, we need to swap these two elements. I will take this element, move it within some temporary storage, like a temporary variable, take the element on the right, move it to the left. Take whatever is within temp, place it within that opening. Again, we take our value, examine the element to the right. If it's larger, we swap them. Then we would just repeat this until we reach the end. So that would be one element. We would repeat this process with the rest of the elements. Now for the next iteration, 1 is not greater than 9, so we leave it alone. Then we check the next element. 9 is greater than 2. We would swap these two values. I'll speed up the footage. That is a quick demonstration of a bubble sort. So let's actually write this in code now. Okay, let's create an array. This will be an array of integers. Make up some numbers, make sure they're not in order. Let's calculate the size of the array. Int size equals size of our array divided by the size of one of the elements. At the end of our program, we will iterate over our array. I'll use a for each loop. Int element in array. I will display using standard output every element, then I think I'll separate each with a space. Okay, and here's our array, obviously unsorted, so let's change that. I'll create a sort function. Void sort. There will be two parameters, an integer array, int size. Let's add a function declaration at the top of our program. Before we print our array, let's invoke the sort function that we just created. Pass in our array as well as the size. There we go. Okay, so let's head to our sort function. What we'll need to do is iterate over our array once for every element that's within the array. We'll need the help of a temporary variable to swap some values. Then we'll need nested loops. For int I equals 0. We'll continue this as long as I is less than the size of our array minus 1. The reason that the condition is size minus 1 is because we don't need to compare the last element to anything. The larger values will naturally gravitate towards the end of the array. Increment I by 1. Then we'll need a nested for loop. Let's use index j because I is already taken. Now our condition is going to be size minus I minus 1. Once we place the larger elements all the way to the right, they should already be in order. We don't need to sort any elements that are already sorted. Then what we have to do is use an if statement to check to see if the current element that we're on, array at index of j, is greater than the element on the right. Array at index of j plus 1. If the element on the left is larger than the element on the right, we just have to swap those two values. We'll take temp which we declared up here, equals array at index of j. Array at index of j equals array at index of j plus 1. Then lastly, array at index of j plus 1 equals whatever's within temp. And that should be it. Let's run this. Yeah, and our array is now sorted in ascending order. So if you need a descending order within the if statement, use less than. And now this array is in descending order. Well, okay then everybody, that's one way in which you can sort an array. We used what's known as a local sort. It's easy to write, but it's not as efficient as some other algorithms that are out there. This is a good one for beginners. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to sort an array using C++. Hey everybody, in this topic I'm going to explain the fill function. The fill function fills a range of elements with a specified value. There's 3 arguments: a beginning address of a down structure, an ending address, then some value. Suppose we have an array of strings. Standard string only in this array foods. I'll give this a maximum size of 10 elements. Then I'll go ahead and fill this array with the same food. I'll fill all 10 elements with the word pizza. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these all have the same value. Now this really isn't practical, although it does work. Just to demonstrate, I'll display the elements with a for each loop. We're displaying strings for every food element in my array, foods. I would like to display each food element. Then I'll add a new line. So we have 10 elements all filled with pizza. You know, this does work, but it's not practical to initialize all of these elements manually. What if we had an array of 100 elements? I would have to type the word pizza 100 times. There's a few solutions, one of which would be the fill function, which would make this process a lot easier. I'm going to declare this array, but not fill it in quite yet. We have an array of 100 elements to store strings. I'm going to fill all 100 elements with pizza. So we type fill parentheses. Now we need the beginning address of the data structure. Well, that's simply the array name. Then an ending address. So that would be the second argument. We would type the array name plus the size of the array. So plus 100 in this case. Then some value. I'll fill this array with the word pizza 100 times. There we go. All 100 elements have been filled with pizza. Now if you do change the size of this array, let's say we have 150 elements, you would have to go and change that within the fill method too. What I would do, in place of adding some number to my array, I will add a size variable. Foods will be index of size, and then we can set some size. Actually, better yet, let's make this a constant. Constant int size. Then I'll set this to be 100. Foods plus size. So again, all 100 elements are filled with pizza. Now here's a few exercises. If I'm filling the first half of this array with pizza, we have our beginning address. Then I need to find the halfway point. Foods plus size divided by 2. I'll just go ahead and put that within some parentheses for clarity. And if I were to run this, the first half of this array contains pizza, and the second half contains nothing. It's empty. To fill the second half of this array with hamburgers, I would invoke the fill function again. We will begin where we left off. Foods plus size divided by 2. The ending address would be foods plus size. We will fill the second half of this array with hamburgers. There we are. The first half is all pizza. The second half is all hamburgers. Here's a challenge round. We'll fill the first third of our array with pizza, the second third will be hamburgers, and the last third will be hot dogs. But 100 doesn't divide by 3 evenly. Just to make it simple, I'll set our array to be 99 elements. We're filling the first third of our array with pizza, size divided by 3. Hamburgers will begin at foods plus size divided by 3, and end at size divided by 3 times 2. And we'll invoke the fill function one more time. We'll continue where we left off. And we will end at foods plus size. And fill this with hot dogs. Here we go. So we have pizza, hamburgers, and hot dogs. So yeah, that is the fill function. We can fill a range of elements with a specified value. It's great if you have a lot of elements to work with, and you don't manually want to type all the values. And if you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the fill function in C++. Hey, welcome back everybody. In this video, I'm going to explain one of the few ways in which we can accept user input and place it within an array. There's no one-size-fits-all way to do it. I'll show you one way that's good for beginners. Let's begin by creating an array. I'll create an array of strings named foods. We're not going to be assigning values to this array quite yet. That's where the user input will come in. If we're not assigning values right away when we initialize this array, we'll have to specify a size. For the time being, let's say 5, something small. Now arrays, they're static data structures. While our program is running, we can't change the size of this array. The max size is stuck at 5. And that might be a problem if we would like to enter in more than 5 items. We'll discuss dynamic memory in a future video. And I'm going to calculate the size of this array. And size equals size of my array foods divided by the size of one of the elements, foods at index of 0. Let's create a for loop to iterate over the elements of this array. For in I equals 0, we'll continue this as long as I is less than the size of our array, then increment I by 1. Let's create a prompt. Standard output, enter a food you like. Then I'll display the number to show the user what number we're on. Then I'm just going to add a colon at the end. If we're working with strings, we should probably use the getLine function, just because what the user enters may contain spaces. Get line standard input. We'll place our input within our array foods at the index of I, whatever we're currently on, our counter. At the end of our program, let's display a message. You like the following food. I'll use a for each loop to iterate over the elements of this array. We list the data type, a name for the current element, food in foods. Let's display standard output, whatever the food is. I'll add a new line, and that should be good. Now take a look at this. Enter a food you like. We're on number 0. I'm going to add +1 to I when we display our prompt. The user's not going to be sure why there's a number 0, but we know that's the beginning index of an array. So I'm just going to change that here. Enter a food you like. We're on number 1. Pizza, hamburger, hot dog, ramen, sushi, and these are the 5 elements. You like the following food: pizza, hamburger, hot dog, ramen, sushi. Okay, that's pretty good so far. Suppose the user only wants to enter in 3 elements, not all 5. We should add some way to escape out of this for loop based on some user input. I'm going to add this line. Enter a food you like or Q to quit. Now check this out. If the user types in Q, we would like to exit. If foods at index of I is equal to the string Q, then I would like to break out of this for loop. The user is done entering an input. But there's a problem with this. Enter a food you like or Q to quit. Number 1, pizza, hamburger, hot dog. Now I'm going to press Q to quit. We don't have any more prompts to enter in food. We went to the results. You like the following food: pizza, hamburger, hot dog, Q. I'd rather not put the letter Q in my foods array. I'm going to create a temporary variable just to hold some user input. This will be the string data type, standard string. I'll name this temp meaning temporary. It's a temporary variable. In place of directly bringing my user input into my foods array, I'll place it temporarily within my variable temp. I'm going to check if temp is equal to Q. Else, we'll say foods at index of I set is equal to temp. That way we're not directly assigning our user input to our array until we check what it is. If the user types in Q to quit, we don't want to put that within our foods array. So let's try this again. It should be better. Enter a food you like or a Q to quit. Pizza, hamburger, hot dog, Q to quit. Okay, pizza, hamburger, hot dog. Well, the letter Q isn't here, but when we display what's within the array, we have these empty spaces. We did not assign a value to these. If one of our elements is empty, I don't want to display it. So we can make this following change. In place of a for each loop, let's use a standard for loop. Int I equals 0. Now here's the condition. We're used to saying I is less than size, right? I'd like to propose a change. We'll write a different condition. I will check if the current element is empty. Foods at index of I dot empty function. Then we'll add the not logical operator. We'll continue our for loop as long as the current element is not empty. Then we'll add a statement, increment I by 1. We'll display our array foods at index of I. This for loop shouldn't display any elements that are empty. Pizza, hamburger, hot dog, Q to quit. Yeah, we only have 3 elements. Pizza, hamburger, hot dog. One disadvantage of arrays is that they have a limited size. They're static. Once we declare a size, we can't change it. We're limited to only storing 5 foods. You could declare a larger size, but you may be wasting memory if the user doesn't want to type in all 10. So in future topics, we'll need to discuss both dynamic memory and vectors, which should be coming up sometime in the future. So yeah, that is one way out of many ways to enter in user input into an array. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's how to enter user input into an array using C++. Hey everybody, in this topic I'm going to explain multi-dimensional arrays, more specifically 2D arrays. It's an array made up of separate arrays. They're useful because they can represent a grid or matrix of data with rows and columns. Here's an example. I'll create a 2-dimensional array of cars, car names. The data type will be string. I will name this array cars. With arrays, they have one set of square brackets. But if you're creating a 2-dimensional array, you need 2 sets of square brackets. The first set of square brackets is for the number of rows. Let's say 3 in this example. The second set of square brackets corresponds to the number of columns. If we have 3 rows and 4 columns, 3 times 4 is 12, so that would give us 12 elements. If you're initializing your 2D array right away, you don't necessarily need to set a row size, but you do need a column size. I'll just set the amount of columns to be 3, just something small. Okay, so let's fill in the first array. This first row will be cars manufactured by Ford. I'll add a Mustang, then a Ford Escape, then maybe a Ford F-150. Okay, this is our first array. I'm going to create a second array. After the first array, I'll add a comma. What I like to do, I like to organize my 2D array kind of like it's a grid. So now we have a second array. This next array will be cars manufactured by Chevrolet. I'll pick a Corvette, then an Equinox, and a Silverado. Let's add one last array. These will be cars manufactured by Dodge. Challenger, Durango, Ram 1500. Alright, now to finish this 2-dimensional array, we will enclose all of these inner arrays with another set of curly braces that add a semicolon to the end. That is our two-dimensional array. You can see that there's rows and columns. In this example, each row corresponds to a manufacturer. So it's kind of like a grid, a matrix. And then if you were to access one of these elements, you need two indices. Just to demonstrate, let's display all of them. Standard output cars. I need to select the row number, then the column number. Row 0, column 0. Let's see what car that is. I'm just going to add a space between these elements. Okay. Row 0, column 0, that's my Mustang. Row 0, column 0, that's Mustang. Let's print the next element. That would be row 0, column 1. That is my Ford Escape. Row 0, column 1. I'm just going to zoom out. There. Then we have row 0, column 2. That's the Ford F-150. I'm going to display a new line character. Now we are on row 1. So let's copy these, paste them. Row 1, column 0, row 1, column 1, row 1, column 2. So this next row is our cars manufactured by Chevrolet. We have our Corvette, our Equinox, and our Silverado. Then we'll display row 2, column 0, row 2, column 1, row 2, column 2. And these are the cars manufactured by Dodge. We have our Challenger, Durango, Ram 1500. So yeah, you can see that a two-dimensional array is kind of like a grid made up of rows and columns. Now if we need to iterate over a two-dimensional array and display the elements, here's one way in which we can do that. We can use nested loops. Well, just to make it easy, I'm going to calculate the amount of rows and columns that we have. Let's begin with the rows. Int rows equals size of my array cars divided by the size of one of the elements. Cars at index 0 again. Then to calculate the amount of columns that we have, we can do something like this. Int columns equals the size of cars at index of 0 divided by the size of one of the elements. So remember there's two indices this time. 0, 0 is good. In this example we should have 3 rows as well as 3 columns. Now let's create a for loop to iterate over the rows. Int I equals 0. I will continue this as long as I is less than the number of rows that we have. Then increment I by 1. I'm going to display cars at index of I just for the time being. Then for now I'm just going to add a new line between each. So notice to display cars at index I, that should give us 3 memory addresses. One address for every inner array. This memory address is for the first array, then the second array, then the third array. What I need to do now to get the elements within each array is to create an inner loop. Let's use an inner for loop to iterate over each element within each array. Int j, because I is already taken, set this equal to 0. We will continue with this for loop as long as j is less than the number of columns that we have. Increment j by 1. Now I'm going to display cars, and there's 2 indices. I, then j. I'm going to display a space between each of these. Okay, now we have one long line of text. So once we escape the inner for loop, I would just like to print a new line. I'll add standard output new line character. Okay, and here's our two-dimensional array. The first row are for cars manufactured by Ford, then Chevrolet, then Dodge. That's how to iterate over a two-dimensional array. You have the outer loop that's in charge of the rows, the inner loop which is in charge of the columns. So that's a two-dimensional array, everybody. It's just an array where each element is its own separate array. You have two indices. The first for the rows, the second for the columns. To access one of the elements, you have to specify the row, then the column that element is found. So those are two-dimensional arrays. Your assignment is to post a two-dimensional array in the comment section down below. And well, yeah, those are two-dimensional arrays in C++. Hey everybody, in this video we're going to create a quiz game using C++. Let's begin by creating an array of questions. These will be of the string data type. I will name this array questions. And then let's think of some questions. Really add any questions that you want. Here's a few that come to mind for me. What year was C++ created? And that is the first question. I'll add an additional string. Question 2. Who invented C++? Third question. What is the predecessor of C++? And I couldn't think of a fourth question, so I'm going to ask, is the Earth flat? Good enough. With each question, there will be 4 corresponding options. I think a two-dimensional array would be perfect for this. This will be a two-dimensional array of strings named options. We'll need to set a number of columns. 4 columns is good. This first array will be for the options for the first question. A will be 1969. B, 1975. C, 1985. 1985 is the correct answer. D, 1989. Now we have our next array. Who invented C++? Guido van Rossum. He's the creator of Python, so that's not the correct answer. Bjorn Stroustrup. I'm sorry if I mispronounced your name, dude. Hopefully you're not watching right now. B is the correct answer in this case. C, John Carmack. D, Mark Zuckerberg. We're on question 3. What is the predecessor of C++? The correct answer is C. That would be option A. C+, C minus minus, or B++. Okay, last question. Is the Earth flat? Yes. No. Sometimes. What's Earth? Alright, then I just need to surround all of these arrays with another set of curly braces. And there is our two-dimensional array named options to hold all of the options for our questions. We'll need to create an answer key next. This will be an array of characters. Answer key array equals, here are the correct answers. C, B, A, then B. 1985, Bjorn Stroustrup. C, the language C that is. And no, the Earth is not flat. I looked it up on Wikipedia just now. Let's calculate the size of our questions. How many questions do we have? Int size equals the size of our array of questions divided by the size of one of the elements. Questions at index 0. We'll create a character to hold our guess. Int score to hold the score. Now we'll need to iterate over our questions. For, let me move down here. Int I equals 0. We'll continue this as long as I is less than the size of our array, the size of questions. This would effectively be the amount of questions that we have. Then I'm going to increment I by 1. We will iterate once through all of the questions we have. Standard output. Let's access the string that's within questions at index I. I'll add a new line. Just for some text decoration, I'm going to add a bunch of asterisks before and after the question. So let's get rid of this. I think that'll look pretty cool. There we go. Then we'll need to iterate over our 2D array. We'll use an inner for loop for that. We'll need a different index. I is already taken. Let's take j. Int j equals 0. We'll continue this as long as j is less than. Now we'll need to calculate how many elements are within each array. So we can do that with size of our options array at index of I divided by the size of options, and there's two indices here, I, then 0. Then we will increment j by 1. We will display our options, standard output, options, there's two indices, I, then j. I'll add a new line. So if I were to run this, this should display all of the questions and all of the options. Yeah, here we are. What year was C++ created? Who invented C++? What is the predecessor of C++? Is the Earth flat? After all of the options are laid out, we will accept some user input, standard input. We will place the user's input within guess. Then just in case the user types in something that's lowercase, like a lowercase c, we're looking for capital C. So let's take the user's guess and make it uppercase. Guess equals to upper pass in guess. So that will capitalize the character the user enters in. Now let's check to see if the user's guess is equal to the answer. We'll need to access the answer key at index of I. That's the current numbers question. If those two values are the same, we will display correct. I'll add a new line, then increment the user score, score plus plus, else the user's guess is not correct. Standard output, wrong. Then we will display the correct answer. Standard output, answer, colon, space. We'll access the answer key at index of I. Then I'll add a new line. Okay, let's try this so far. What year was C++ created? C. Who invented C++? That would be B. What is the predecessor of C++? That is C, the language C, but it's option A. Is the Earth flat? What's Earth? D. Okay, wrong. Answer B. Okay, so we know that we can cycle through the questions. Outside of the for loop, we will calculate the player score. So right here, I'll display the word results, standard output, results. I'll add a new line. Actually, now that I think of it, I'm going to steal some of these text decorations. Let's make it look pretty. Something like this would look cool, but not necessary. standard output correct guesses. Then we will display the current score. Add a new line. Standard output. Number of questions. That is simply the size of our array. Add a new line. And we will calculate a percentage. What percent of the questions did they get right? Score. Score divided by size times 100, and then we'll add percent. So at first, this isn't going to work because we're using integer division, but I'll explain that momentarily about typecasting. So let's run this once. Let's say A, B, C, D. Correct guess is 1. Number of questions, 4. Our score was 0%, even though we got one right. We'll need to add a cast to the divisor. Let's cast size as a double that decimal portion. Then this should work. A, B, C, D. Correct guess is 1. Number of questions, 4. Our score was 25%. Now let's go for 100. Remember that the correct answers are C, D, A, B. 1985, Beyond Scroll Strip. The language C, but that's option A. Is the Earth flat? No. B. Correct guess is 4. Number of questions, 4. Score 100%. Well, yeah, everybody, that is a quiz game you can make in C++. You can impress your friends or have your friends take the quiz. You can change your questions around if you want. And if you'd like a copy of this code, I'll post this in the comment section down below. And that is a quiz game written using C++. Hey everybody, welcome to the exciting world of memory addresses. A memory address is a location in memory where data is stored. In C++, a memory address can be accessed with an ampersand, known as the address of operator. Suppose we have some variables. I'll create a string. The variable name will be named. Assign this a string of text. I'll create int age, set this equal to some value. Then a boolean. Boolean student, I'll set that to be true. A variable is a container for some data, but these variables need to exist somewhere. Well, they exist in your computer's memory at a given address. We can find that address with the address of operator. I'll display that. Standard output. I would like to display the address of name. I'll just add a new line. Here's the address of my name variable in my computer's memory. It's a bunch of weird letters and numbers. Well, this is a hexadecimal address. Every time we run this program, that number is likely to change. Let's display the addresses of age and student. Address of age, address of student. Here's the memory addresses. Again, all in hexadecimal. So these are kind of like street addresses. Hey, for fun, let's decode these to decimal. You can easily find tools online to convert hexadecimal to decimal. Let's see what these numbers are. Here are the hexadecimal memory addresses, but converted to decimal. They're like house numbers. Different data types take up more or less room than other data types. If we look at the distance between my name variable and age, well, that has a gap of 4 memory addresses, but the gap between my age and student variables is only 1, because, well, booleans only take up 1 byte of memory. That's one of the reasons we use data types. We need to know how much memory we need to allocate to fit a certain value. If we're working with a boolean variable, well, we only need 1 byte of memory. That's why the distance between the memory address of age and student is only 1. 40 minus 39 is 1. Integers take up 4 bytes of memory. 44 minus 40 is 4 bytes. So that's an introduction to memory addresses. It's going to be helpful in the next topic when we discuss pointers. If you would like a copy of this code, I'll post this in the comment section down below, and that is an introduction to memory addresses in C++. Alright everybody, so I'm going to explain the differences between pass-by-value and pass-by-reference. In this example, we'll swap two variables. Suppose we have two imaginary cups. I'll name the first cup X. X will contain Kool-Aid. Then we have cup Y, which contains water. I need to swap these two values. We'll need the help of a temporary variable, string a temp. To swap two variables, we would assign a temp equal to X. X equals Y. Y equals temp. Let's display these variables. Standard output X. The variable X. I'll add a new line. Let's copy this, paste it. Y, the variable Y. This should work. X now contains water, Y contains Kool-Aid. Now check this out. What if we create a function to swap two variables for us? The return type will be void. I'll name this function swap. There will be two parameters, string X, string Y. Let's copy this section of code, delete it, then paste it into the swap function. Then you'll need a function declaration at the top of your program. Then we will invoke this function. Swap, pass our arguments, X and Y. Let's see what happens. Okay, what the heck? X still contains Kool-Aid, Y still contains water. These values weren't switched within my variables X and Y, even though we invoked this function. So why didn't it work? Well, that's because normally when we pass a variable to a function, we're passing by value. When we invoke this function, we're creating copies of the original values. What we have now are two copies of the variable X and Y, and all we're doing is switching the two copies and not the original values. So that's pass by value. We're creating copies of the arguments. If I need to change the original values of these variables, I could instead pass by reference. A reference as in a memory address, an address in your computer's memory where a value is located. I will prefix the address of operator, which is an ampersand, to these parameter names. Then add that to your function declaration as well. Now let's see what happens. Yeah, those two variables were switched. X contains water, Y contains Kool-Aid. When we pass by value, we created copies of X and Y with the parameters. When we use the address of operator, we're passing memory addresses to where the original X and Y variables are located, and then swapping the values. Just to reinforce this idea, let's revert to passing by value. I'm going to display the address of X and Y. Then within our swap function, let's get rid of this code. Then I will also display the addresses of X and Y. See, we have four different addresses. Our original X variable has a different memory address than the one that's within the function. Same thing goes with Y. These two addresses are different. We have two X variables and two Y variables. Originally within that swap function, we were switching the values of the X and Y copies. If we instead pass by reference, let's use that address of operator again. Well, now X and Y are referring to the same place. They have the same memory addresses. That's why the swap function works when we pass by reference in place of pass by value. So that's the main difference between pass by value and pass by reference. You should use pass by reference as often as possible, unless you have a reason to pass by value. If you'd like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's the main difference between pass by value and pass by reference in C++. Hey everyone, in this topic I'm going to explain const parameters. A const parameter is a parameter that is modified with the const keyword. That makes it effectively read-only. There's a couple reasons why you might want to declare a const parameter. Your code is more secure within a function, and it conveys the intent to other programmers. It's especially useful for references and pointers. Here's an example of const parameters in action. I have standard string name, assign your first name, then int age, whatever your age is. Then suppose I have a function to print my info. Void print info. And there will be two parameters. Standard string name, int age. Be sure to add a function declaration if you're missing it. Then if I need to call this function, I would invoke the function name, pass in my arguments, name, age. Then we can print our info. Standard output name, standard output age. This of course does what you expect. It prints our name and our age. To make this function more secure, we can instead use const parameters. That means that we can't change the values that we receive, name and age in this case. Just as a test, let's set name equal to an empty space and age equals 0. I don't want this to be able to happen at all. Now when I run this, we don't have a name and we don't have an age. To make these parameters read-only, we can precede the parameters with that const keyword. Const string name, const int age. And you would probably want to add that to your function declaration as well, just to display intent. There we have it here. Assignment of read-only parameter. Age and name is somewhere up here, but I don't feel like reading all that. When we pass our string and our integer as arguments, what we're doing is effectively making a copy of name and age. Technically, we're not modifying the original variables. In this case, using the const keyword when we pass a variable by value isn't really that big of a deal, but it at least conveys intent. If we were working with reference data types, now we'll pass by reference. Well, now it's a bigger deal. We don't want anybody modifying the original name and age variables. Alright everybody, those are const parameters. They are parameters modified by the const keyword that effectively make them read-only. Within a function, your code is more secure, and it conveys intent. It tells other programmers, hey, don't mess with these values. They're useful with references so that nobody can change the value found in that reference. Then in the case of pointers, nobody can change the address of where a pointer is pointing to. So yeah, those are const parameters in C++. Hey everybody, in this topic, we're going to create a program to validate if a credit card number is valid or not. To do so, we'll need to utilize the Loon algorithm, which I've broken into these steps. If you need to test credit card numbers, you can always Google them. I found a bunch on this website. Let's just take this one for example. And to make this more readable, I'll divide this number into groups of 4. Step 1, we double every second digit from right to left. If the double number is 2 digits, split them. I'm only concerned with every second digit from right to left, so we can eliminate some of these that we won't be using. Then we're going to double these numbers. So 2 doubled is 4. 9 doubled is 18. Since we have the number 18, that's 2 digits. We need to split them. We'll split 18 to 1 and 8. Then 6 doubled is 12. We'll split that. Step 2, we need to add all of these numbers together to create a sum. The sum is 29. Step 3, add all odd number digits from right to left with the original number. So now we're only concerned with the odd numbers. Then we just add these numbers together. No need to double them. The sum is 21. Step 4, we sum the results of steps 2 and steps 3. 29 plus 21, that equals 50. Step 5, if step 4 is divisible by 10, that number is valid. We could say our result, modulus 10. If that number is divisible by 0, that number is valid. 50 is divisible by 10, so that number is valid. We'll create a program that will do all of this for us. Let's create our functions. We'll need 3. Int, get, digit. The parameter will be a constant integer that I will name number. Int, const standard string card number. Let's copy this, paste it, sum even digits. The parameter is the same. Let's copy these functions and add some declarations. We do need to return something, otherwise we'll get a warning. For the time being, I'm just going to return 0 as a placeholder. Okay, let's begin with the main function. We'll need a credit card number. That will be a string, standard string card number, then int results, and I will set that equal to 0 right away. We'll prompt the user to enter in their credit card number, standard output, enter a credit card number, standard input, card number, results equals, we'll invoke the sum even digits function, pass in our card number, plus sum odd digits, pass in our card number. We'll need to fill in these functions. Let's begin with sum even digits. We can get rid of this. I'll create a local variable named sum to keep track of the sum. What we'll need to do is iterate over our card number in reverse order. We can treat a string as an array of characters, and we can iterate over that. So we'll need a for loop. And we will iterate over this card number in reverse order, starting from the end. We'll need an index, its I, equals. Then we'll need to find the size of our card number. There's a built-in function for that. Card number dot size. Now arrays, they always start with 0, so we're going to subtract 1. However, if we're summing the even digits, beginning from the right, we'll need the second to last digit. So that would actually be -2. The very last digit would be -1. Our index I will begin from the second to last position. I would like to continue this for loop as long as I is less than or equal to 0. Then we will decrement I by 2. I minus equals 2, because we need every even digit. So we will take sum plus equals, then invoke the getDigit function. GetDigit. Within the getDigit function, as an argument, we're going to pass in card number at index of I times 2. However, there's one more thing that we'll need to do. With card number at index of I, we will subtract the character 0. And here's why. We're currently working with a string of characters. You can also treat a string as an array of characters. Each character, according to the ASCII table, has an associated integer value, a decimal value. If I'm passing one of these characters as an argument to my getDigit function, we'll treat that character as if it was its decimal equivalent. According to the ASCII table, the character 0 has a decimal value of 48. The character 1 is 49, 2 is 50, then all the way up to 9, which has a decimal value of 57. So if I'm passing in the character at index of I, what we'll end up working with is the decimal representation of that character. If we subtract the character 0, or its equivalent, 48, that would give us a range of numbers 0 through 9. For example, the decimal equivalent of the character 9 is 57. 57 minus 48 would be 9. You could subtract either 48 or the character 0. That would give us numbers 0 through 9, according to the ASCII table. Then we're multiplying that number by 2. Then at the end, we will return whatever the sum is. Let's fill in this getDigit function. Within the getDigit function, the digit that we're working with was doubled. Whatever number we passed in, it may take 2 digits. For example, like 9 times 2 is 18. We need to split those 2 numbers to get 1 and 8. So I'm going to return number modulus 10 plus number divided by 10 modulus 10. That will split the 2 numbers. For example, let's say our number that we're passing in as an argument is 18. 9 times 2. 18 modulus 10 would give us 8. 18 divided by 10. That would give us 1, since we're using integer division. 1 modulus 10 is 1. 8 plus 1 is 9. Then we're just returning that number, 9. Okay, that is the getDigit function. Then we need to sum the odd digits. And really, we can just copy all this, then paste it. But there's a couple changes to make. It's I equals card number dot size function minus 1. We need to begin at the end. And then sum plus equals card number minus 0. When summing the odd digits, there's no need to double the odd digits. That's only with the even digits. And that is all the functions. Let's close out of these. So we'll have a result, the sum of the even digits plus the sum of the odd digits. If result is divisible by 10, that number is valid. If result modulus 10 is equal to 0, then that number is valid. Standard output, card number is valid. Else, card number is not valid. Okay, let's try this. I'm going to enter in that original number that we worked with, that Discover card. Okay, I have a credit card number. I'm going to paste this, hit enter. That number is valid. Let's try that again. So I'm going to enter in the same card number, except I'll add 1 to the end. That number is not valid. Hey, if you have your own credit cards, feel free to try them too and see if it works. Alright everybody, that is a credit card validation program mostly for practice. If you would like a copy of this code, I'll post this in the comment section down below. Please be sure that you do not enter in your own credit card into the comment section. And well, yeah, that is a credit card validation program using C++. Alright everybody, we finally made it to pointers. A pointer is just a variable that stores a memory address of another variable. That's it. The reason that we use pointers is because, well, sometimes it's just easier to work with an address. Here's an example. I have a stack of maybe 20 pizzas that I'm going to give out for free to my neighborhood. Instead of going around house to house carrying the free pizza and handing it out, it's a lot easier to go door to door and tell people where the pizza is located. Hey, there's free pizza at my house at this address. Come and get some. And that's one of the uses of pointers. Sometimes it's easier to just work with an address. I'll tell people where the free pizza is, rather than carry it around with me. So when working with pointers, we'll need to use the address of operator, which is an ampersand, as well as the dereference operator, which is an asterisk. Let's begin with the name. I'll create a pointer to a name. Standard string name. Assign your first name. And we'll create a pointer to name. Where is my name located in my computer's memory? To create a pointer, it should be in the same data type as the variable is pointing to. I'm creating a pointer to a string. This pointer will be in the string data type. Then type asterisk. That is the reference operator. Then a common naming convention for pointers is you type P, then the variable name. But I'm going to make the first letter uppercase. I will set this pointer equal to the address of that name variable. And there we go, we have a pointer. So if I was to display this pointer, standard output, P name, my pointer contains this value. It contains a memory address as its value. To access the value of this address, you would use the dereference operator. I'm accessing the value of that address that's stored within this pointer, which contains my first name. By using this dereference operator, I'm accessing the value that's at this given address, which contains my first name. Let's create a couple other pointers. Let's create a variable age, int age equals make up some age. I'll create a pointer to age. The data type of the pointer should be the same as the variable. Int dereference operator, key age equals the address of age. Then let's display whatever value is located at the address that's stored within my pointer of pH. So we have my first name and then an age. I think I'm just going to add a new line real quick. Going back to that analogy with the free pizzas, I'll create an array of strings. I'll name this array free pizzas. I'll give this a size of 5. We have pizza 1, pizza 2, pizza 3, pizza 4, and pizza 5. Like I said in my example, it's a lot easier instead of carrying around 5 free pizzas house to house, giving away pizza. I can just tell people where the pizza is located. I'll give them an address. I'll create a pointer to this array. We'll use the same data type for storing strings. The reference operator, key free pizzas. Now I'm going to attempt to set this to the address of free pizzas. Now we're going to run into a problem. My array is already an address, so I don't need to use the address of operator. Let me demonstrate. I will display cout free pizzas. When accessing my array free pizzas, it's already a memory address. If I display the value contained within my pointer to my free pizzas, it's going to be a memory address. Then if I was to use the dereference operator, that would give me the first element within that array, pizza 1. So those are pointers. It's a variable that stores a memory address of another variable. Sometimes it's easier to work with an address. Instead of carrying 5 free pizzas with me and going house to house giving it away, I'll just tell people where the free pizza is. So those are pointers. Your assignment is to post a pointer in the comment section down below. And well, yeah, that's an introduction to pointers in C++. Hey, what's up everybody? So let's talk about null pointers, but first we'll need to know what a null value is. A null value is a special value that means that something has no value. When a pointer is holding a null value, that means that pointer is not pointing to anything. That's what we would call a null pointer. There is a keyword that represents that, null PTR. PTR meaning pointer. It's a keyword that represents a null pointer literal. One of the reasons that we use null pointers is that they're helpful when determining if an address was successfully assigned to a pointer. If we create a pointer, but don't assign it a value, we don't know where it's pointing to. It would be good practice that that pointer doesn't point anywhere. So let's create a null pointer. I'll create a pointer of the int data type. We use the dereference operator. Pointer. If I'm not going to assign this pointer an address right away, it would be good practice to assign this pointer null PTR, null pointer. Later on in your program, if you need to assign an address, let's say int x equals 123, I would just take my pointer, set this equal to the address of my variable. If you dereference a null pointer, it can lead to undefined behavior. Or if you dereference a pointer that's not assigned a value, well, that can lead to undefined behavior too. What some programmers do is that they'll check to see if their pointer is a null pointer before continuing, kind of like a system of checks and balances. We assigned our pointer the address of x. I would like to check to see if my pointer contains a valid address before dereferencing it. So we could say pointer equals null pointer. Was my pointer assigned an address, or is it still a null pointer? If my pointer is still a null pointer, that means we did not successfully assign an address to my pointer. There may be situations, such as when working with dynamic memory, where you attempt to assign an address to your pointer and it fails. This would be a good way to check to see if that failed or not, if your pointer still remains a null pointer. So let's say address was not pointer is pointing to the address of X. Address was assigned. Now, if for some reason we do not assign an address, I'll turn this line into a comment to represent that. Well, our pointer is still going to be a null pointer. Address was not assigned. If your pointer is still a null pointer, it's not safe to dereference that pointer. If I need access to the value that's at that pointer, it would be safe to do so within this else statement. Standard output, dereference operator, pointer. So my pointer contains the number 123. If I were to dereference this null pointer, that would lead to undefined behavior. I have no idea what's going to happen. Don't try this at home, kids. A null pointer is a keyword that represents a null pointer literal. When declaring a pointer, it's good practice that our pointer is pointing to a valid address or this null pointer keyword, because otherwise we don't know where it's pointing originally. They're helpful with determining if an address was successfully assigned to a pointer. When using pointers, be careful that your code isn't dereferencing a null pointer or pointing to any free memory that we're not using, because that can lead to undefined behavior. So yeah, everybody, those are null pointers in C++. Hey guys, in this topic we're going to create a game of tic-tac-toe. We'll be working with random numbers. You may or may not need to include this header file. Include C time. We'll add some function declarations and some definitions. Void draw board. There will be one parameter. A pointer to an array named spaces. Spaces will be a one-dimensional array that will keep track of all the markers, like what spots are taken, what spots are occupied. Player move. The parameters will be a pointer to spaces and a char player. Computer move. A pointer to spaces, char computer. Check winner. A pointer to spaces, char player, and char computer. Then lastly, check tie. And all we need is a pointer to our array spaces. Check winner and check tie will both return a Boolean value. Okay, let's add some function declarations. So after the main function, let's paste these. We do need to return some value for check winner and check tie because there is a return type. Just for now, as a placeholder, I'm going to return 0. Well, we'll change that later. Let's head to the main function and declare everything that we'll need. A character array named spaces. The size will be 9 spaces. We'll have 9 elements. Each contains an empty space. One, two, three, four, 5, 6, 7, 8, 9. Good. Char player. Pick a character that you'd like to be. You can do acts or something else. Char computer. Take a character from the computer. Let's begin with O. Boolean running. All sets equal to true. When we begin our game, we will immediately invoke the drawBoard function, then pass in our array. So remember, when we pass an array to a function, it decays into a pointer. So we don't need to create a pointer for this array. Within the drawBoard function, we will display a grid. So let's write something like this. Standard output, I'll add 5 spaces, 1, 2, 3, 4, 5, then a vertical bar. 5 spaces again, 1, 2, 3, 4, 5. Vertical bar, 1, 2, 3, 4, 5. Then a new line. Okay, let's copy this line. Right in the middle, I'm going to add one of the elements of our array, spaces. So right about there. Spaces at index 0. I'm going to copy this section of code. Right in the middle between the two vertical bars, I'll paste what we copied. Spaces at index 1. Then again, right in the middle, paste what you have. Spaces at index 2. This one will create a horizontal bar. Let's copy this. We'll replace the spaces with underscores. So right about there. Okay, let's see what we have. Okay, yeah, something like this. We'll have a player or the computer right in the center. So let's copy this line on top, paste it underneath, copy this line that displays elements of our array, paste it underneath, but change the elements numbers 3, 4, 5. Then we'll copy this line, paste it underneath. Let's double check to see what we have. Okay, we're getting somewhere. Let's copy this line, paste it. Copy one of these lines where we display the elements of the array. Paste it underneath. So we are missing elements 6, 7, 8. Let's copy one of these empty lines. Paste it underneath. Then before and after we display this grid, I'll just display a new line. Standard output. New line, and let's do that after. Okay, let's see what we have. Yeah, not too bad. There's our grid of 9 spaces. Okay, that is the drawBoard function. We can close out of this. We're done with it. When we invoke the drawBoard function, we will pass in our array, which decays to a pointer, and then prints our board. Let's add a while loop after the drawBoard function. While our condition is running is set to true initially. When we exit out of the game, we'll set running to be false. The first thing that we'll do is invoke the playerMove function. PlayerMove, but we need to pass in our array, spaces, as well as the player. Then let's fill in the playerMove function. Okay, playerMove. I'll create a local variable named number. The user will enter in a number between 1 and 9. Depending on what space they'd like to occupy with their marker, I'll create a do while loop. Do while the condition will be not number is greater than 0, or not number is less than 8. The user can only enter in a number between 0 and 8. Those numbers correspond to the elements of our array, elements with indices 0 through 8. Within the do while loop, we'll ask for some user input, standard output, enter a spot to place a marker 1 through 9. Whatever the user types in, we'll just subtract 1, because the user doesn't know that arrays start with 0, supposedly. Standard input, number. So the user will enter in a number between 1 and 9. Then we will decrement the number by 1, because the array starts with 0. If spaces at index of number, whatever the user types in, is equal to an empty space. If that space isn't occupied, we'll add that marker to that spot. Spaces at index of number equals the player's marker. Then we'd like to break out this while loop. So after the player moves, let's draw the board again to reflect any changes. Okay, enter a spot to place a marker. How about 1? Yeah, there's our marker. Let's try it again. How about 9? Yeah, and we are in the last spot, the bottom right corner. Let's enter in a number that's outside of its range, like 100. Enter a slot to place a marker, -1. Okay, so we're limited to the numbers 1 through 9. Even if I were to type 0, we still can't. So let's try something in the middle. That would be 1, 2, 3, 4, 5. Yeah, and there's a marker. I'm just going to add a colon and space. Okay, and that is the player move function. We can close out of this function. Let's work on the computer move function next. Within the while loop, let's invoke that function, pass in our spaces array, as well as whatever character the computer is. Then we will draw the board again right after. Just to update it. Within the computer move function, we'll create a local variable named number. We'll need a seed to generate a random number, srand, within the parentheses, invoke the time function, pass in 0 or null, and we should be able to generate some random numbers. So I'm going to create a while loop. While the condition will be true, I would like to generate a random number between 0 through 8. We'll take number set is equal to rand function modulus 9. Number will be random between 0 and 8 technically. If we pick a spot number that's occupied already, we'll need to re-roll a random number. If spaces at index of number is equal to an empty space, we'll take spaces at index of number, set is equal to the computer's marker, then break out of this while loop. Let's test this function. After we pick a spot, the computer will pick a spot too. Yep, so the computer picked a spot right in the middle. Let's try it one more time. I'll pick the spot in the middle again, so that would be 5. And our computer picked spot number 2. Cool. Let's close out of the computer move function. After the player moves, then we draw the board again. We will check a winner. I'll use an if statement. Within the condition of the if statement, we will invoke the check winner function. The check winner function returns a Boolean value, so that's why we're placing it within the if statement. We'll need to pass in a couple arguments: our spaces, the player, and the computer. If there's a winner, if this evaluates to be true, we will set running equal to false, and we will break. Let's add this if statement to after the computer moves too. Okay, let's run the check winner function. So right down here, we'll need to check all of the different win conditions. There's several. Normally I would use a switch, but it's going to get very complicated, especially for beginners. I think just to make this easier, we'll use a bunch of if and else if statements. Within the first condition of the if statement, we'll check to see if the first row all has matching characters. So we can do that by saying spaces at index of 0 is equal to spaces at index of 1 and spaces at index of 1 is equal to spaces at index of 2. If all 3 characters in the first row are the same, that means that somebody won. I'm going to use the ternary operator here. We have to determine who won, the player or the computer. Let's check to see if the first index, spaces at index 0, is equal to the player's marker. Ternary operator, like we're asking a question. If the player occupies the first row, then we'll print standard output you win. Otherwise, standard output you lose. Then I'm just going to add a new line here and here. Yeah, there's one more thing we have to do with this condition, and I'll explain that. So let's run this. I'll pick spot number 9. You lose. The reason that we lost is that we're checking to see if the first row all has the same characters. They're technically all empty spaces, so our program thinks that somebody won because all of these characters matched. There are 3 empty spaces. I'm going to amend this if statement. We'll want to ensure that none of the spaces are empty. And really, we only need to check the first space. I'll make this amendment. Spaces at index of 0 does not equal organized, you can always surround some of these conditions with parentheses. I think it's more legible that way. Let's try that again, just to be sure that it's working. I'll pick something in the middle. Okay, yeah, so the computer doesn't win automatically if there's 3 empty spaces in the first row. Okay, so that is the first win condition. Let's copy this condition. I'll add else if. Now we'll check the second row. If spaces at index 3 is not equal to an empty space, and spaces at index 3 is equal to spaces at index 4, and spaces at index 4 is equal to spaces at index 5. Then does spaces at index 3 equal the player? Okay, so that is row 2. Let's copy and paste that else if statement. Then we'll need to check the last row. Spaces at index 6. 6 is 6 equal to 7, and is 7 equal to 8. So these conditions will check all of the rows. Then we'll need columns. Let's copy one of these else if statements, paste it. So we have 0, 0 is 0 equal to 3, and is 3 equal to 6. Okay, now time for the second column. Spaces at index 1, 1 right here as well, is 1 equal to 4, and is 4 equal to 7. Copy this again, paste it. Then we have the third column. 2, 2 is 2 equal to 5, and is 5 equal to 8. Okay, now the diagonals. Spaces at 0, 0 is 0 equal to 4, and is 4 equal to 8. Then the last diagonal. Spaces at index 2, 2 is 2 equal to 4, and is 4 equal to 6. If there's no win conditions, we'll have an else statement. We will return false. Then all we have to do at the end of this function is to return true. Somebody won. Okay, so let's test this. I'll try and win with the first row. 1, 2, 3. You win. This time I'm going to try and lose. 1, 2, 4, 7. Oops, 7's taken. 8. There we go. You lose. We can close out of the check winner function. We know that it's working. Then we just need to check to see if there's a tie. If there's no more spaces available within the main function, after our if statements, we'll add else if. We'll invoke the check tie function, pass in our spaces. Check tie returns a Boolean value if it's true. We will set running to be false, then break. Then add that after the computer move section 2. So right here. Then let's fill in this function. Within the check tie function, we'll iterate over the elements of our array spaces. We'll use a for loop. For int I equals 0. We'll continue this as long as I is less than 9 because there's a total size of 9 spaces. Increment I by 1. If spaces at index of I is equal to an empty space, that means we can continue. Return false. There's still empty spaces. If we iterate over our array and there's no empty spaces, well, that will display standard output. It's a tie. I'll add a new line. Then we will return true. And we can get rid of that. Okay, so let's close out of this check tie function. Then after we exit our game, outside of this while loop, let's display a message. Standard output, thanks for playing. Alright, and that's everything. Let's run this. I'm going to try and get it high this time. 1, 2, 6, 7, 8. This is high. Thanks for playing. Alright everybody, that is a game of tic-tac-toe for beginners. If you would like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's a game of tic-tac-toe using C++. Hey everybody, we finally made it to dynamic memory. Dynamic memory is memory that is allocated after the program is already compiled and running. To allocate dynamic memory, we use this new keyword as an operator. It allows us to allocate memory in the heap rather than the stack. It's useful when we don't know how much memory we'll need. It makes our programs more flexible, especially when accepting user input, because we have no idea what the user is going to type in. Here's an example. We'll start with a basic integer variable. But we'll allocate memory in the heap rather than the stack by using that new keyword. I'll create a pointer. Int the reference operator, p_num. Now it's good practice when you declare a pointer, but don't assign it right away, to give it a value of null, meaning no value. To allocate memory in the heap rather than the stack, I'll take my pointer, set is equal to, use the new operator, then a data type. I'll use up enough space in the heap for one integer. The new operator will return an address. We're storing that address within p_num because it's a pointer. It's pointing to a memory location where we're going to store an integer. Later on in your program, whenever you would like to store a value, we can use the dereference operator, our pointer, and then assign some value, like 21. I don't know. Just for fun, I'm going to display the address that's stored within the pointer. Address p_num, then I'll add a new line, as well as the value the reference operator, p_num. Our pointer is storing this address, and at this address in the heap, that address contains this value, 21. Now it's very good practice, if not expected, whenever you use the new operator, you'll also want to use the delete operator when you're no longer using that memory space. So at the end of this program, or earlier if you choose, we will delete our pointer. Delete p_num. We're freeing up the memory at this address. If you don't, you may cause a memory leak, and it's best to avoid that. Whenever you use the new operator, you probably should be using the delete operator someplace within your program. Here's another example. We're going to dynamically create an array. Let's create an array of grades. Char, then we'll leave a pointer, the reference operator, p_grades. Set is equal to null, if we're not going to assign this pointer right away. Then to dynamically create an array, we will take our pointer, set is equal to new, the data type, char. If this is an array, we add a set of straight brackets. Within the straight brackets, we will list the size. If I have 5 grades to enter in, I will type in 5. But if we already know the size of the array before we even run the program, we might as well do that normally, like create a normal array. There's no point to allocating memory dynamically. We would want to do that when we don't know what the size is going to be. So I propose we ask for some user input. Let's say int size. We'll create a prompt. Standard output. How many grades to enter in? Standard input size. Will dynamically allocate enough memory in the heap depending on how many grades the user has to enter in. I'll just create a for loop so that we will ask the user to enter in some grades. In I equals 0, I will continue this as long as I is less than size. Increment I by 1. Standard output. Enter grade number I plus 1 because I will be 0 to begin with. And I'm just going to add colon space afterwards. Standard input key grades as a pointer. Now we can either add plus I or use those straight brackets at index of I, either way. Let's display all of the grades. Int I equals 0, I is less than size, I plus plus, standard output, key grades at indexes of I. I'll separate each with a space. And remember, if we no longer need this array, we should delete it to prevent a memory leak. If we have to delete an array, we'll have a straight brackets after delete, then our pointer, key grades. And let's try it. How many grades to enter in? So we don't know what the user's going to type. Let's say 6 grades. Enter grade 1, A, B, C, D, F, A. Enter the grades. So that's why dynamic memory is useful. It's memory that is allocated after the program is already compiled and running. We use the new operator to allocate memory in the heap rather than the stack. It's useful when we don't know how much memory we will need. It makes our programs more flexible, especially when accepting user input. So that is an introduction to dynamic memory. We'll have more practice with this in the future, so don't worry. If you would like a copy of the code that we worked on, I'll post that in the comment section down below. And well, yeah, that's an introduction to dynamic memory in C++. Hey guys, I gotta explain recursion. Recursion is a programming technique where a function invokes itself from within. We break a complex concept into repeatable single steps. Many problems we can approach iteratively or recursively. Some of the advantages of recursion include less code to write, and typically it's cleaner. It's also useful for sorting and searching algorithms. However, some of the disadvantages of recursion is that it uses more memory and is slower. There's a trade-off. It's up to you if you'd rather use an iterative approach or a recursive approach. Here's an example. We'll break a complex concept, maybe such as walking, into repeatable single steps. To accomplish the task of walking, we would take a single step and then just repeat that a bunch of times. We'll do this first iteratively, then recursively. So let's create a function to walk. Void walk. There will be one parameter, a number of steps. Let's define this walk function. We'll use an iterative approach first. To do that, we can use a for loop. We'll set int I equals 0. We'll continue this as long as I is less than our steps. Then increment I by 1. I will display just you take a step. Then I'll add a new line. So we will invoke this function, pass in how many steps we would like to walk. I would like to walk 100 steps. And here we go. We printed, you take a step 100 times. This is an iterative approach. If we were to take a recursive approach, we would invoke this function from within itself. So I'm going to turn this for loop into an if statement. We'll need a base case. When do we stop? If steps is greater than 0, we will display you take a step. Then I'm going to invoke the walk function from within itself. Then I will pass in steps minus 1. This would be a recursive approach. We're invoking the walk function from within itself. You'll end up in a function, within a function, within a function, within a function, so on and so forth. So when I run this would do the same thing, but we've done so recursively. The advantages with recursion is that the code tends to be easier to write. I find this if statement a lot easier to understand than that for loop, although they're both pretty simple. However, with recursion, it uses more memory and it takes more processing time. In the case with our walk function, I would probably stick with an iterative approach. There's really not much benefit in this case. But in the case of, let's say, a searching algorithm or navigating a tree data structure, recursion would really help us with that. So let's say we don't have a base case. That's when we stop. What if I just call the walk function forever? Well, we end up in an infinite loop, and we would encounter what's called a stack overflow. When you invoke a function, you add what's called a frame to the stack. When your stack is overloaded, you'll encounter a stack overflow. So that's one problem with recursion. So let's try a different example. We'll create a factorial function. you don't remember, factorial is a mathematics concept where you take a number and you multiply that number times the previous number minus 1 times the previous number minus 1 times the previous number minus 1 until you reach 1. You multiply all these numbers and you're given a result. I'm going to demonstrate a function to do that both iteratively then recursively. Let's begin with an iterative approach. We will return an integer. This function will be named factorial. We'll pass in an integer named num. I'll immediately display the output, standard output, factorial, then pass in some number, maybe 10. Let's define this function. If I was to take an iterative approach, I would write something like this. Int result, this will be a local variable. I'll set this equal to 1. I'll create a for loop. Int I equals 1. We'll continue this as long as I is less than or equal to our number. Increment I by 1. I will take our result equals result times whatever I currently is. At the end of this program, we will return result. Factorial 10, that would be 3,628,800. If I was taking a recursive approach, I would write something like this. We would need a base case. When do we stop? If num is greater than 1, we will return num times invoke factorial again, our number minus 1. Else, we will simply return 1. This would do the same thing, but recursively. Factorial 10 is 3,628,800. Those were two different approaches to the same problem. When we did this recursively, we have a function call inside of a function call, inside of a function call, inside of a function call. You get the idea. Personally, I find a recursive approach to be a lot easier to read and understand. Although remember, it uses more memory and is slower. When you start to learn about sorting algorithms, that's when recursion is really going to help you quite a lot. It will simplify the steps. So that's recursion, everybody. It's a programming technique where a function invokes itself from within. We break a complex concept into repeatable single steps. Whenever you see a function invoking itself from within, you'll know that that's recursion. If you'd like a copy of this code, I'll post this in the comment section down below. And well, yeah, that's recursion in C++. Hey everyone, let's discuss function templates. A function template describes what a function looks like. It can be used to generate as many overloaded functions as needed, each using different data types. How is this useful? Suppose we have a max function that will accept and return an integer. Int max, the parameters will be int x, int y, will return, I'll use the ternary operator here, is x greater than y? If so, return x. If not, return y. This function is compatible with integers as arguments. Let's display standard output max, then pass in two integers like 1 and 2. So this would return the number 2. But what if I would like to use this function with doubles, such as 1.1 and 2.1? Well, we're truncating that decimal portion. We're returning 2, not 2.1. If I want this function to be compatible with doubles, normally I would have to create an overloaded function that accepts doubles and returns a double. Replace int with double. And I guess this would work technically. The value returned is 2.1. What about characters? How about the character 1 and the character 2? Technically, we could use the max version that accepts integers because there's an associated ASCII value with each of these characters. But I would like an overloaded function that accepts and returns characters. Char, char, char. So this would return the character 2. This is a lot of work creating 3 overloaded functions that each do the same thing. The only difference is that they accept and return different data types. What if we could write one function that will accept any data type? Well, that's what function templates are. To create a function template, take your function, replace any data type with t. We're returning an integer, let's instead return t. The data type of x will be t, same thing with y. Using t as a common naming convention, I like to think of it as thing. Like we're not sure what the data type is, we're returning a thing. That's just how I think of it. However, our compiler doesn't know what t is exactly. We'll need to add a template parameter declaration. Before this function template definition, we'll add a declaration of what t is. So type template, angle brackets, type name, t, and that's it. This function template will work with many data types: characters, doubles, integers, you name it. So yeah, just replace the data type with t. Then be sure to add a template parameter declaration. But here's a scenario. What if you need to mix and match the data types? I'll find what the max is between the integer 1 and the double 2.1. Well, we have a problem. No matching function for call toMax int double. With this function template, it's only set up to receive arguments of the same data type. Now we're passing in two different data types. What we could do within our template parameter declaration is add another template name. I'm going to add type name u because u comes after t in the alphabet. Then if you needed more, you could add v, w, x, so on and so forth. I'll change one of these t's to a u. This function template is set up to receive up to two different data types as arguments. But there's one more change we need to make. So we don't have that error anymore, but the decimal portion of our double is truncated. It's returning 2. That's because we're still returning t, and t we set to be an integer in this case. So we set the return type to be t or u. Actually, better yet, we can set this to auto. Using the auto keyword, the compiler will deduce what the return type should be. This should return 2.1. Alright everybody, that is a function template. It describes what a function looks like. They can be used to generate as many overloaded functions as needed, each using different data types. I like to think of it like a cookie cutter. We're determining what the shape is, but the arguments, the dough that we use for our cookies, can be different, but the cookies will end up having the same shape. One of the main benefits of using function templates is that we only have to write a function once, and then it's compatible with different data types. So you don't need multiple versions of the same function. We'll generate functions using this template as needed. So yeah, those are function templates, everybody. Your assignment, if you choose to do so, is to write a function template in the comment section down below. And well, yeah, those are function templates in C++. Well, okay then everybody, we got to talk about structs. A struct is a structure that groups related variables under one name. Think of an array. An array can store multiple values of the same data type. Well, a struct can store multiple values of different data types. We can store strings along with ints, doubles, booleans, etc. To create a struct, let's do so outside of the main function. Type struct. Then we need an identifier. This is kind of like the data type. Suppose we're going to group related variables for students. I'll name this identifier student. Within the structure of student, variables that we declare are known as members. I think each student should have a name member. This will be of the string data type, string name. I'll declare this but not yet assign it, as well as the GPA. That can be of the double data type. Then a Boolean variable if they're currently enrolled or not. Enrolled. Then be sure to end your struct with a semicolon. Our struct student is kind of like its own data type. We can use this data type to declare variables. I'll create a student variable of this data type, and that variable will have these three different members: a name, a GPA, and a Boolean variable for being enrolled. Much like with creating a variable, we type the data type, student, and then some names, some identifier. Let's name the first student, student1. Student1 will have its own name, GPA, and enrolled status. If I would like to assign the name member of student1, I would type the name of the student, student1, followed by a dot. Members can be accessed with a dot, also known as the class member access operator. I'll assign the name member and set this equal to SpongeBob. I'll I'll assign student 1's GPA. Student1.GPA. I'll give SpongeBob a solid 3.2. Then I could set his enrolled status. Student1.enrolled. I'll set this to be true. And then we could access these members. I'll display them. Standard output student1.name. I'll add a new line. Let's do the same thing with GPA and enrolled. Student1.GPA, student1.enrolled. This is what this looks like. We have a student variable. The name member is SpongeBob. SpongeBob has a GPA of 3.2. When accessing Boolean variables, 1 corresponds with true, 0 corresponds with false. Enrolled is set to true, so that would return 1. Let's reuse the struct to create a second student. I'll just copy what we have here, then paste it. We'll give the second student a different identifier, such as student2. Student 2 will have a name member of Patrick, a GPA of 2.1, and he will be enrolled. That's set to true. Let's display student 2's members. Student2.name, student2.GPA, then student2.enrolled. These first members correspond with student 1, SpongeBob 3.2, 1 for true. The second set is for student 2. Patrick has a GPA of 2.1, and Patrick is currently enrolled. Okay, one last example. Let's create student 3. Let's copy what we have, paste it. Student3, student3.name, student3.GPA, student3.enrolled. Student 3's name will be Squidward. Squidward has a GPA of 1.5. Let's set enrolled to be false. Then display student 3's members. Student3.name, student3.GPA, student3.enrolled. And here are student 3's members. Squidward, 1.5, and 0, that means false. Now with members, you can set a default value. I'll set enrolled to be true. Then we don't need to explicitly state that. Underneath SpongeBob, Patrick, and Squidward, their enrolled member is all set to 1. With members, you can set a default value. So yeah, those are structs. It's a structure that groups related variables under one name. Structs can contain many different data types. Variables in a struct are known as members, and members can be accessed with a dot, the class member access operator. So those are structs. Your assignment is to post a struct in the comment section down below. And well, yeah, those are structs in C++. Hey everybody, in this topic I'm going to show you how we can pass a struct to a function in C++. Suppose we have a struct. The identifier of the struct will be cars. Then we'll create some members related to cars. How about a model, standard string model, a year, int year, then a color, standard string color. Then let's go ahead and create 2 car structs. How about car, car1, car2. Then we'll assign the members. Car1, model, pick a model of the car that you like. Then a year, and a color. Let's do the same thing with car2. Car2.model, car2.year, car2.color. Let's take some different data. That'll work. Suppose we have a function to display the members of the car. Void. How about print car? We're printing the members. We'll need some parameters. The data type of what we're passing in are car structs. So we'll list that as the data type. Then some nickname for the argument that we received. How about just car? Then I will display the members. Standard output car.model. Should probably add a new line too. Then do the same thing with year and color. Car.year, car.color. Let's test this by printing car1. Print car1. We will pass the name of a struct as an argument. Then I think we're just missing a function declaration, so if you're missing that, be sure to add that. There. Now let's run this. Okay, here's our car. Mustang 2023, and the color's red. Now with structs, they're passed by value rather than passed by reference. If we pass a struct as an argument, what we're doing is creating a copy of the original struct. To demonstrate that, let's display the address of car1 before and within the function. Standard, output, address of operator, car1. I'll add a new line. And let's do that within the function too. The parameter name is car, not car1. There. So let's try that. So these addresses are different. When we pass the struct to a function, the function will create a copy of it. It's passed by value. We're displaying the members of the copy rather than the original. If you need to work with the original struct, you can use the address of operator. We're passing a reference to the original car struct. Then be sure to change that within the function declaration as well. So let's take a look at the addresses now. Yeah, these addresses are the same. Car2 is feeling pretty lonely, so let's print car2 as well. Print car, pass in car2 as an argument to this function. So we should have car1 and car2. This time, let's change one of the members within the function. Let's create a function to paint car. Paint it a different color. Paint car. There will be two arguments. An address to a car, as well as a color, which will be of the string data type. Be sure to add a function declaration if you're missing it. Then within this function, we will take our car.color equals the new color that we received. Now before we print our cars, let's paint them a different color. Paint car. We have two arguments this time, a car struct and a new color. Let's paint our Mustang silver. Then let's paint car2 maybe gold. Then let's display this. Okay, our Mustang is now silver and our Corvette is now gold. So if we didn't use the address of operator when painting our car, let me show you what happens. Our cars are still the original colors, red and blue. What we did within this function is that we created a copy of our car structs and changed the color of the copies rather than the originals. So if you need to make any changes to the original, you would want to use the address of operator. So that's how to pass structs to functions. You can pass by value, which can be expensive, or you can pass by reference. Your assignment, if you choose to do so, is to post a function that accepts a struct as an argument. And that's how to pass structs to functions in C++. Hey everybody, we gotta talk about enums. Enums also means enumerations. It's a user-defined data type that consists of paired named integer constants. They're great if you have a set of potential options. Here's an example. Suppose we have a day of the week. Standard, string, today. Then pick a day. I'll pick Sunday. Normally you can't use strings within switches, but we can use enums, which are kind of similar. Let me explain. So I'm going to create a switch. We will examine today. Normally we can't do this because it's a string. We'll examine today against many matching cases. Case, Sunday, and I'll speed up the footage. Okay, here's my switch. Depending on what day of the week it is, we'll display a custom message. It is either Sunday through Saturday, one of these days. So normally we can't use strings within switches. This is what happens when we attempt that. Error, switch quantity, not an integer. Something similar that we can use are enums. They're paired named integer constants. We have a name and an associated value. They're interchangeable. At the top of my program, I will declare enum, then a name for this set of enumerations. Let's say day, or day of the week. Monday, Tuesday, and you know the rest. You can associate a value with each of these names. Sunday equals 0, Monday equals 1, then we'll just continue on with the rest of these. And I'm going to group these together like that. Okay, we have our enum set up. This identifier is kind of like the new data type. We're not working with strings anymore, we're working with days. These are a set of potential options. Each option is a pair of a name and some associated value. You can really pick any value. I went with the numbers 0 through 6 to represent the days of the week. I'm going to set today to Sunday, this name. We can now use this within a switch. There's an associated integer value, but we'll change the cases from strings to that enum data type. And this would work. It is Sunday. Within the cases, you could use the associated values as well. I'm going to change today to be Friday. Case 0 is Sunday. Monday is 1, 2, 3, 4, 5, 6. It is Friday. So that also works, but I don't think it's as readable. Another cool thing with enums is that enum variables take only one value of the set. If I try and make up some value like pizza day, well, we can't do that. Pizza day was not declared in the scope. Here's a few other enum examples. You could create a set of enums for flavors: vanilla, chocolate, strawberry, mint. An important note is that if you're working with enums and you don't assign an integer value to each of these names, you'll implicitly assign 0 to the first name, then 1, 2, 3. Kind of like what I did up here, but we explicitly assign those values. We have 6 colors, or maybe planets. I have a set of enums of the 9 planets in our solar system. The associated integer is the size of each planet in kilometers. So yeah, those are enums. They're a user-defined data type that consists of paired named integer constants. They're great if you have a set of potential options. Your assignment is to post a set of enums in the comment section down below. And well, yeah, those are enums in C++. Hey everybody, so we have finally made it to object-oriented programming. An object, think of it as a collection of attributes and methods. Attributes are characteristics of an object. Methods are functions that an object can perform. Objects can be used to mimic real-world items. So look around you right now. Next to me I have a phone, a book, and a dog. Think of attributes as characteristics. What kinds of characteristics would a phone have? Maybe a version number, a charge, a service provider. Objects can also contain methods. What kinds of actions can a phone perform? They can make calls, receive calls, play games. Now with a book, some of the attributes of a book could be maybe an author, number of pages. Let's see, what kinds of methods can a book perform? Really not much. You can open a book and you can close it, so those are just a few. Okay, lastly, how about a dog object? Some of the attributes of a dog could be a name, an age, maybe a breed of dog. And what kinds of actions can dogs perform? They can eat, they can bark, they can sleep, maybe play fetch. So I think you get the idea. An object is a collection of attributes and methods. Now to create an object, we can use a class. A class acts as a blueprint to create objects. Let's create a class to create human objects. I will type class human, curly braces. I'm going to add a public access modifier. We'll learn about access modifiers pretty soon. I would like these attributes and methods to be publicly accessible. Let's start with the attributes of humans. What kinds of characteristics can humans have? How about a name? This will be of the string data type. I'll declare this attribute, but not yet assign it. Maybe an occupation, like a job. Standard string occupation. Then maybe an age. int age. Our class human has these attributes. Humans have a name, an occupation, and an age. That's good enough for this example. Now let's cover methods. A method is a function that belongs to a class. It's something that an object can do, an action it can perform. What sorts of actions should our humans be able to perform? How about an each method? Void each. I'll just display a message, standard output. Let's say this person is eating. Humans can drink. Void drink. Standard output. This person is drinking. And one last example. How about sleep? Humans sleep, right? Void sleep. Standard output. This person is sleeping. Good enough. To make sure we add a semicolon to the end of the class. Perfect. Okay, so we now have a human class. We can use this class as a blueprint to create human objects. Each human object will have a name, an occupation, and an age. They can also eat, drink, or sleep. They have their own functions, which we call methods. So to create a human object, we will type the name of the class, human, then a unique identifier. How about human1? That's creative. So human1 is an object. Human1 has a name, an occupation, and an age, but we have not assigned these attributes. Let's say human1's name, human1, member access modifier, which is a dot, name equals Rick. Then human1's occupation equals scientist. Human1's age equals 70. Let's verify that this works by printing out these attributes. Standard output human1 dot name. I'll add a new line. Then let's repeat this for occupation and age. Human1 dot occupation, human1 dot age. Human1's name is Rick. His occupation is a scientist. His age is 70 years old. So this part is kind of similar to structs. However, objects can also perform actions. They have methods. Rick can eat, drink, and sleep. So to invoke those methods, I will type the name of my object, human1, and let's have human1 eat. So human1 dot eat, add a set of parentheses to invoke this method. Okay, this person is eating. Let's also test drink and sleep. Human1 dot drink, human1 dot sleep. Okay, this person is eating, and this person is drinking, and this person is sleeping. And that is our human, human1. For more practice, let's create a second human. Human2. I'm going to copy these lines. Let's change human1 to human2. Human2's name will be Morty. Occupation will be student. Age, what about 15? I'm going to display the attributes of human2 this time. Then I'll have human2 invoke its methods. Eat, drink, then sleep. Okay, human2's name is Morty. Their occupation is a student. Morty is 15 years old. Then Morty can perform these actions. Eat, drink, and sleep. Now you can assign some default attributes. So let's say that all humans we create will be named Rick. It's kind of like we're cloning him. His occupation will be scientist. Age will be 70. I'm not going to assign these attributes. What I did is that I added some default attributes. So we have human1 and human2. I'll display the attributes of human1 first, then human2. Human1.name, occupation, age, Then we have human tooth attributes as well. So remember, I am not assigning these attributes within the main function. We have two humans. They're both named Rick, they're both scientists, and they're both age 70. Okay, now here's one last example to really get the hang of objects. Let's create a different class this time. How about cars? Class car. Let's add a public access modifier. Now what kinds of attributes would cars have? Perhaps a make, standard string make, a model, standard string model, a year, that would be an int, then maybe a color, standard string color. You can add some default attributes, but I'll just leave those empty for now. You can add some methods. What kinds of actions can cars take? I guess you can accelerate. Void accelerate. Standard output, what can we print? You step on the gas. Then maybe brake. Void brake. Standard output. You step on the brakes. Then be sure to add a semicolon to the end of your class because I always forget to do that. Okay, we now have a car class. It acts as a blueprint to create car objects. To create an object, we would type the name of the class, car in this example, then a unique identifier for the object. Let's say car1. Then we can assign some of the attributes of this car object. Car1 dot make, maybe Ford. Car1 dot model equals Mustang. I like Mustangs. Car1 dot year equals 2023. Then a color, car1 dot color, maybe silver. Okay, then just to test these, let's print these attributes. Standard output, car1 dot make, add a new line. Let's copy this line, paste it 3 times. Then we'll display the model, year, then color. Okay, our car object is a Ford Mustang. The year is 2023. The color is silver. Not only does our car have attributes, but it has methods, actions it can perform as well. Our car can accelerate and it can brake. Let's test that. Car1 dot accelerate. Car1 dot brake. Okay, you step on the gas, you step on the brakes. Then if I need a second car object, I can type car, car2, then I can assign the attributes, and I have access to its methods. So yeah, that's an object, everybody. It's a collection of attributes and methods. Attributes are characteristics of an object. Methods are functions that an object can perform. So yeah, those are objects, everybody. In the next video, we're going to cover constructors. Your assignment is to post a class in the comment section down below. So yeah, that's an introduction to object-oriented programming in C++. Hey everybody, welcome back. So in today's video, we're going to discuss constructors. A constructor is a special method within a class that is automatically called when an object is instantiated. It's useful for assigning values to attributes as arguments. Before, when we were assigning attributes to an object, we would say, for example, car1 dot make equals Ford. Well, with a constructor, we can do that automatically. Here's an example. This time, let's create a student class. Class student. I'll add a public access modifier. What attributes should students have? How about a name? Standard string name. Int age. Double GPA. Sounds good to me. And then if I need to create a student object, I would type the name of the class, student, a unique identifier for this specific object. Let's say student1. Then to assign some of the attributes right away, I could use a constructor. We do have a constructor that is automatically called behind the scenes. but we could explicitly set one up. The constructor has the same name as the class. In this case, student, add a set of parentheses, add a set of curly braces. Think of this as a function. We can set up parameters. When we instantiate a student object, we will automatically call this function the constructor, then pass arguments. Let's set up some parameters. We have standard string name, int age, double GPA. Then when I instantiate a student object, I will add a set of parentheses after the object name, then pass in my arguments. Let me just zoom in real quick. Okay, in order to instantiate a student object, we need to pass in a name, an age, and a GPA. So for the first student, student 1's name will be SpongeBob. His age will be, I don't know how old SpongeBob is, let's say he's 25. SpongeBob's GPA will be a solid 3.2. When we instantiate our student object, we will pass these values as arguments to the constructor. Now, to assign these attributes with these parameters, we first need to select these attributes. In this example, I gave them the same name, just to remove ambiguity. If I'm referring to these attributes, I will type this, then an arrow, name equals the name of the parameter, name. This name equals my name parameter. This arrow age equals my age parameter. This arrow GPA equals my GPA. So now let's test this. I will display student 1's name, age, and GPA. Standard output, student 1 dot name, add a new line, then we have age, then GPA. Okay, we got SpongeBob, he's 25 years old, his GPA is 3.2. So you can see that we don't need to necessarily add these values to these attributes manually. You can do that automatically with a constructor. So another way in which you may see this constructor set up is with the parameter names being different from the attribute names. Perhaps instead of name, age, and GPA, let's say X, Y, then Z. If the attribute names are different from the parameter names, you don't need this keyword. You could say name equals X, age equals Y, GPA equals Z. And this would work too. If you prefer this way of doing things, you can do that. It's just my own personal preference. I like to use this keyword and then keep my parameters the same. But that's just me. You do you. Let's create a couple more students. And it's kind of nice because we can reuse this constructor. Let's create student 2. Student, student 2. Student 2 will be Patrick. I don't know how old Patrick is. Let's say Patrick is 40. Patrick's GPA will be 1.5. Okay, to test this, let's display student 2's name, age, and GPA. Okay, we got Patrick, he's 40 years old, GPA is 1.5. One last student. Student 3. Student 3 will be Sandy. Sandy is about 21 years old. And Sandy's GPA is a perfect 4.0. And now we'll display student 3's name, age, GPA. Okay, we got Sandy. Her age is 21. GPA is 4.0. Let's do one last example just to reinforce our understanding of constructors. Let's create an entirely new class. Let's go back to our car class. I'm going to get rid of all this. So we need a class car, set of curly braces, add a semicolon to the end. I will add a public access modifier. In the last topic, we decided that cars have 4 attributes: a make, standard string make, a model, standard string model, int year, standard string color. Now we'll create a constructor for our car objects. It has the same name as the class name, car, set of parentheses, parentheses, set curly braces. We can set up some parameters. We have make, model, year, and color. I think I'm just going to copy this to save time. You can rename these if you want, but I like to keep them the same. Then I will assign this arrow make equals make, this arrow model equals model, this arrow year equals year, this arrow color equals color. When we create a car object, we'll need to pass in these arguments. I will create car1, add a set of parentheses, pass in my arguments, a make, model, year, and color. I'll create a Chevy Corvette. The year will be 2022. The color is blue. I'm going to display the attributes. Standard output, car1.make. I'll add a new line. Then I will display the model, year, and color. Model, year, color. Car1 is a Chevy Corvette. The year is 2022. The color is blue. Let's create a second car. Car2. Car2 will be a Ford Mustang. The year will be 2023. The color will be red. I will display Car2's attributes. We have a Ford Mustang. The year is 2023. The color is red. So yeah, that's a constructor, everybody. A constructor is a special method that is automatically called when an object is instantiated. It's useful for assigning values to attributes as arguments. When you create an object from a class, add a set of parentheses, then add your arguments. Within the constructor, you can assign those arguments to the attributes of that class. In the next topic, we'll cover overloaded constructors. If you're looking for some additional practice, in the comment section down below, post a class that contains a constructor. And well, yeah, those are constructors in C++. Overloaded constructors are when we have multiple constructors with the same name but different parameters. They allow for a varying number of arguments when instantiating an object. Here's an example. We'll create pizza objects from the pizza class. Let's type class, pizza, add a set of curly braces, a semicolon to the end. We'll make our members publicly accessible. So pizzas, they can have a variable number of toppings, right? You can have no toppings, one topping, two toppings, three toppings. Suppose we have just one topping to begin with. Topping 1. And that will be of the string data type. Standard string topping 1. Then I will create a pizza constructor. It has the same name as the class name, pizza, parentheses, curly braces. We'll set up some parameters. Standard string topping 1. In order to construct a pizza, we have to pass in one topping. So let's do that. We have pizza, pizza 1, and I will pass in one argument for a topping. I feel like pepperoni. Then we'll just need to assign this argument to this attribute. This arrow topping 1 equals topping 1, the name of this parameter. Then to test this, let's display topping 1. Standard output pizza 1 dot topping 1. Okay, we have pizza 1 that contains pepperoni. Now what if you would like a pizza that has two toppings? Suppose we have pizza 2. Pizza 2. This time I'm going to attempt to pass in two arguments. How about mushrooms and peppers? Well, when I run this program, we're going to have an error. Error, no matching function for call to pizza with two arguments. We can create an additional constructor that accepts different arguments. Let's copy what we have and paste it. This constructor will take two string arguments, topping 1 and topping 2. So we have two toppings this time, and I should probably create another attribute for a second topping. Standard string topping 2. This topping 2 equals topping 2. So now with pizza 2, let's display topping 1 as well as topping 2. Now pizza 2 contains mushrooms and peppers. What if you would like a pizza with no toppings, like a plain cheese pizza? Well, we can set that up. Pizza 3. I'm going to attempt to add a set parentheses after pizza 3 by passing in no arguments. But wait a warning, our compiler is saying we should get rid of the parentheses. If we're passing in no arguments, we don't need that set of parentheses, but we still have an error here. No matching function call for pizza with no arguments. If we're creating an object and passing in no arguments, we'll need a matching constructor. So at the top, I'll create a pizza constructor with no arguments. And that should make that error go away. So this should run and compile just fine then. Yep, no errors. So yeah, those are overloaded constructors. You can have multiple constructors with the same name as long as the parameters are different. We have 3 constructors with the same name. We can create a pizza with no toppings, 1 topping, or 2 toppings. Overloaded constructors allow for multiple objects with a varying number of attributes. If you're looking for some additional exercises, post a class with overloaded constructors in the comment section down below. And well, yeah, those are overloaded constructors in C++. Hey everyone, let's talk about getters and setters. Getters and setters are used within this concept of abstraction, where we hide any unnecessary data from outside of the class. Getters are functions that make a private attribute readable. Setters are functions that make a private attribute writable. Here's an example. I'm going to create a stove object, class stove, and I will instantiate a stove object, stove. In previous topics, when we created attributes, we would use the public access specifier, then write any attributes. In this example, let's say int temperature. Well, I'll go ahead and set this to 0 right away. Since this attribute temperature is public, it is accessible from outside of the class. That means that people can change it. For example, I will take my stove object, set the temperature attribute to a really high setting that doesn't exist, like 1,000,000. And define that I can display the temperature. Standard output, temperature setting is stove.temperature. The temperature setting is 1,000,000. I don't want people to mess with my temperature attribute. What I could do instead is set these attributes to be private. We're following that rule of abstraction. We're hiding any unnecessary data from a user that they don't need. We no longer have access to this temperature attribute from outside of the class. You can see we have some red underlines. Temperature is private within this context. This is a hidden attribute from the outside world. If I need access to the value found within this temperature, I can write a getter. It's a function that will make an attribute readable. I'll add a public access specifier, then write a getter. We're returning an integer. I'll write get, then the attribute name, temperature. All I'm going to do is return our temperature. I can no longer update or change the temperature. It's readable but not writable, so I'm going to turn this line into a comment. In place of accessing this attribute directly, I'm going to invoke the getTemperature method. Stove.getTemperature, add a set of parentheses. Now the current temperature setting is set to 0. Adding a getter will make an attribute readable. if you need a private attribute to also be writable, you can add a setter. Void set temperature this arrow temperature equals our temperature that we pass in. Then we just need a parameter, int temperature. In order for a user to change the temperature, they would need to invoke the setTemperature method. Then they can pass in a new temperature. Using the setter, they can still set the temperature to whatever they want, like 1,000,000 in the previous example. The temperature setting is set to 1,000,000. Within a setter, we can add some additional logic or checks. Before we do set the temperature, let's check to see what the temperature is. If the temperature the user passes in is less than 0, we will set this temperature to be 0. Else, if the temperature is greater than or equal to 10, suppose we put a knob with different settings, the numbers 0 through 10. This temperature equals 10. In case they type in 1,000,000, it'll just max out at 10. Else, this temperature equals temperature. I could attempt to set the temperature to 1,000,000, but it would just max out at 10. Or we could try a negative number like -3. Well, now the temperature setting is set to 0, as if the stove was off, or anything between, maybe 5, something right in the middle. The temperature setting is 5. So yeah, that's kind of the purpose of getters and setters. They make a private attribute either readable or writable, or both if you use both. One additional step you can take too is that if you have a constructor, you can invoke the setters within a constructor. Within my stove class, I have a constructor. If we were to receive a temperature, we could set the temperature right away. So we already have this line of code within our setter, so we don't necessarily need this line again. We would instead invoke the setter. Set temperature, pass in our temperature. Then if I was to instantiate a stove object, I would have to pass in a temperature. I'll set it to be 0. And this temperature setting is set to 0. So yeah, those are getters and setters, everybody. A getter makes a private attribute readable. A setter makes a private attribute writable. Within the getters and setters, you can perform additional checks or logic, which is pretty nice. If you're looking for some additional practice, post a class that has a getter and setter in the comment section down below. And well, yeah, those are getters and setters in C++. Hey guys, let's talk about inheritance. Inheritance is when a class can receive attributes and methods from another class. The receiving class is known as a child class. The class that's being inherited from is known as the parent class. It's kind of like how children will inherit their parents' genes and some of their physical traits. It's kind of the same concept. A benefit of inheritance is that it helps to reuse similar code found within multiple classes. Here's an example. We will create an animal class. The animal class will be the parent class. Class animal. I'll make these members publicly accessible. All animals will have a Boolean attribute that we will name alive. If you're an animal, you're alive. Then let's add a method. Maybe an eat method. All animals should be able to eat. Void eat. We'll just print a generic message. Standard output. This animal is eating. I'm going to create two classes, a dog class and a cat class. They will inherit from the animal class. Let's begin with dog. Class dog. To inherit from another class, you would add a colon, then public, the name of the parent class. Dog will inherit from the animal class. Then a set of curly braces, semicolon at the end, and we now have a dog class. Now check this out. If I create a dog object, it will have a Boolean variable named alive as well as an eat method. So let's create a dog object. Dog, dog. So I'm going to display that Boolean variable. Dog dot alive. If I display this attribute, this will give me 1, which means true. This dog object also has an eat method. Dog dot eat and a set of parentheses to invoke it. This animal is eating. So even though there's nothing within this dog class, it's inheriting everything from within the animal class. And we could add some additional attributes and methods as well. Maybe just a method this time. I would like to give my dog the ability to speak. So let's make this public. Void. Maybe barking. Standard output. The dog goes woof. My dog is alive and it can eat. My dog can also bark as well. It has its own attributes and methods too. I would like my dog to bark. Okay, my dog is alive. That's set to 1. The animal is eating. The dog goes woof. So now let's create a cat class. Class cat. The cat class will inherit from the animal class. I'll make its members publicly accessible. I will give cats a meow function. Void meow. Standard output. The cat goes meow. There. Okay, now we can create a cat object. Cat, cat. Let's print the alive Boolean variable of my cat. Cat.eat. Now I'm going to try and use the bark method of a cat, which we don't have. Let's attempt to use that. So class cat has no member named bark. That's because that method is found within the dog class and not the cat class. Cats have a meow method. I'm instead going to use the meow method. Our cat's alive, the animal is eating, the cat goes meow. So that's kind of how inheritance works. A class can inherit attributes and methods from another class. It helps with code reusability. You know, technically you could add these attributes and methods to each of these classes. For example, I'll just add the Boolean variable alive to each of these classes, as well as the eat method. You know, this would work too, but we're repeating ourselves. And with programming, we try not to repeat ourselves if we don't have to. Especially because if we have to make a change to the eat method, let's change each to nom nom nom. Well, I would have to go to each class and make that change manually. And that could be inconvenient if I have hundreds of different classes. It would be a lot easier if I just had to make that change in one place. So I'm going to revert all those changes. If I need to make a change to one of these methods, I'm going to change eat to display nom nom nom. Well, then I just have to make that change in one place, instead of for every individual class. Let's try another example. We'll create a class named shape. This will be the parent class. We'll make the members publicly accessible. Any class that inherits from the shape class will have a double attribute that we will name area, or surface area, double volume. In this example, we won't have any methods this time, just some attributes. I'm going to create class cube. Cube is the child class. It will inherit from the parent class shape. So colon, public, the name of the parent, shape. Even though there's nothing within my cube class has an area and volume attribute. Then let's make a sphere class. Class sphere. There we go. I'm going to add a public access modifier. All cubes will have a double side property. Then with spheres, they will have double radius. Then I'm going to add a constructor for both cubes and spheres. Let's begin with cube. Cube, then sphere. In order to instantiate a cube object, I need to pass them aside as an argument by constructor. construct an object. Double side. Then for the sphere, we need a radius. Double radius. I think what we'll do is that when we construct a cube object and a sphere object, we'll calculate the area and the volume based on either the side that we pass in for a cube or the radius for a sphere. Let's begin with the cube. First, let's assign the length of the side. Remember, with a cube, the length, the width, and the height are all the same. This arrow side equals side. To calculate the area, we can use this formula. So this area equals side times 6, because there are 6 sides to a cube. Then if you need the volume, you can say this arrow volume equals side to the power of 3. We could just say side times side times side just to keep it simple. Now with the sphere, it's a little more complex. First, let's assign the radius. This arrow radius equals radius. Let's calculate the area of the sphere. This arrow area equals, to calculate the area of a sphere, that would be 4 times pi, let's just say 3.14159, times radius squared. So radius times radius. Now let's calculate the volume. This arrow volume equals, to calculate the volume of a sphere, the formula is 4 divided by 3 times pi times radius cubed. So that would be 4 divided by 3.0. Make sure to divide by 3.0 and not 3, because in this case we would be using integer division. We would like to keep that decimal, so 3.0 times pi, that's 3.14159, times radius cubed. To keep it simple, we can say radius times radius times radius. And there we go. Okay, so let's create a cube object to begin with. Cube. I'll name this object just cube. Then in order to construct a cube object, we need to pass in the length of a side. Let's say 10. So my cube class inherits the area and volume attribute from the shape class. Within the constructor of the cube class, we will calculate what the area and the volume is going to be. And I will display that. Standard output area cube dot area. Then I'll add centimeters. Then let's do the same thing with volume. Volume cube dot volume. If the length of the side is 10, the area is going to be 600 centimeters squared. The volume is 1,000 centimeters cubed. Now let's try this with our sphere. Sphere. I'll name this object sphere. Then we will pass in the radius. Let's say 5. I would like to display the sphere's area and the sphere's volume. The area would be 314 centimeters squared. The volume is 523 centimeters cubed. So yeah, that's inheritance, everybody. A class can inherit attributes and methods from another class. If you have multiple classes and they share similar attributes or methods, you can place them within a parent class, and all of those individual classes can inherit from that one common class. It helps with code reusability, and you don't have to repeat yourself. If you're looking for some additional practice, post a parent class and a child class in the comment section down below. And well, yeah, that's an introduction to inheritance in C++.